putting on my Airspace kind of challenging the way that we deal with these in the airspace system. So, for instance, there are scan eagles or that size class that can get up knots across the ground. Works because everybody around them is doing 200, 300 knots, and now I've got a guy up in there that is not. And to make it worse, he's not heading off in a straight line. He's doing persistent surveillance, so he's making right-hand turns up there. That's a problem set for integration. So what I'm saying is, you know, again, you can always approach if 2 pounds and under doesn't get it, but you can prove that the kinetic energy of your 4-pound aircraft equals the same as the potential risk of a 2-pound because of the transibility fuel, that kind of thing. You can have that discussion. Those are the kinds of discussions you can have, right? But you need to have the baseline set. So but weight is a lot easier.
Hi, my name is Jesse. I'm working on a startup, NorCal Unmanned Aero. And you mentioned in the beginning of your presentation that you guys are not against small business, you're for small business. And as a startup owner, how can I use a potential equipment vendor such as yourself, who stands to profit enormously off of businesses like mine, how can we use your existing resources with the regulations and industry groups to help us along? Can you help sponsor our efforts? Can we utilize your lobbying arm and help move these rules forward? It's going to help us get into business, and it's going to make you guys a ton of money when you finally get.
Yeah, you know, that's a good question. I think to the degree that we're all pursuing the same kind of open doors, I think that makes sense. What we have to be careful about is the nature of the dialogue that's accompanied with that, right? So it's difficult. So I was kind of kidding. I didn't bring my Kevlar, but I feel sorry for Jim. I mean, I had to sit in that seat, and anytime you come here, it's like, oh God, what am I going to face from the crowd? We want to help, right? But you can't approach the hill on one side saying, look, sit down with a Northrop Grumman or with somebody. This is what we want to help push forward. At the same time, take a rabid dog that's going out of control that I got to keep on a leash, that kind of thing. So those kind of arguments, you got to balance them. I know you're frustrated, but hollering and screaming and doing all these other kinds of things doesn't really get you a whole lot at the end of the day. You really kind of need to work the system. And Patrick, I know, look, Patrick, I've known Patrick for 10 years. You should have seen him 10 years ago, right? He's had his rabies shot. He's a little bit better now, but he's still a little bit energetic.
Well, I have a 14-year history of being certified by the FAA for operations and maintenance, so I fully advocate working from within the system. And I agree that it does nobody any good to have a bunch of clowns running around, you know, flying these things and injuring people.
But we need the confluence. We need the voice, right? We need the uproar. So we need the confluence of all that coming together. I agree with you. All right. Am I out of time?
Yeah, you're kind of. Oh, no, this guy's waiting. One last
yeah,
question.
All right.
Got to be quick.
Okay.
Got to be quick.
Okay, so my name's Hunter. I'm currently developing a department at my company for farming, the application of these drones in farming and agriculture. I'm going to be real quick with my question and skip everything else. Will agriculture's clarity on regulations be expedited, knowing the fact that agriculture's applications are in lower population areas with limited liability? Permission from property owners is relatively clear and quick, so the communication, the line of communication and privacy is very clear, and the economic benefits appear to be more readily available. I think agriculture is one of the sectors that can benefit.
I agree with you. I think they're a great place to go do some proof of concept work and a great way to be able to prove the viability, both in the ability of the aircraft to fly, to do what you tell it to, the onboard equipment to be able to do the data gathering, and then the operational environment, whether it's a hazardous one. Yeah, it's great. It's great
do you think our regulations are going to be expedited and it's going to become a little bit more clear for us?
I don't know that I would say it's expedited. I would just kind of stand up as a community and say, look at us first. We think we're low risk.
Relatively small.
I don't know.
No one knows us. How many of us?
Look. Don't look at it from that perspective. Look at it from who your state senators are, right? Who your governors are. You got to look at it from that perspective. Don't look at that. So.
Well, thank you very
All
much.
Right.
Okay. Our next speaker is Wolfgang. Oop, I misspelled your name. So we'll go right on. And he's going to talk about LiDAR. But before we do that, can I ask the people in the booths in the back to maybe keep it down a little bit because the people in the back are having a hard time hearing? So that's one request back there. And then I have somebody's credit card. And if you don't come up and claim it, I'm heading for Vegas. Wait a minute, I need my glasses because I can't even read it. It's a Sky Miles card. Richard Humphrey. We have a winner, is that you? Okay. The other thing, Lacey, the audio is not working off the computer. So maybe we need to pot that up a little bit. Wolfgang, are you in the room? There he is right here. Everybody, please welcome Wolfgang. He's going to talk about LiDAR.
Well, thanks a lot for having me here, Patrick and Emil. Actually, this is my second time here, and however, I do see a lot of new faces, so I have to back up a little bit. So what I showed last time was a proof of concept flight that we had done a couple of days earlier before this conference, where we put one of our HDL32 LiDAR devices on an octocopter, went to San Diego, to the football stadium there, and we flew around the football stadium and took that point cloud. And last year I showed that video. I kind of assumed most people have seen it, that's why I didn't bring it this time. But actually a lot of things have happened in that 1 year. Well, it's not even a year, it's less than 12 months. So at that point, we're at that point of proof of concept flight where we're showing the point cloud. And by now, actually, I want to show you some more customer applications that have established since then. And people that are not familiar with LiDAR, well, LiDAR is a measurement technology that's used for measuring 3 distances. Essentially, it's a distance measurement. When you see the guys out there, actually on the construction site, I saw one, you see the guys with the tripod and they're doing these measurements of the streets. That's what LiDAR is. You send out a laser pulse, the pulse goes out, it gets reflected from a surface, it comes back, and the time that it takes to go that distance back and forth, you can determine the distance from the speed of light. Well, the trick that we do is, we don't do it with a tripod shot by shot. We actually have 32 lasers in this device that are spinning, and we shoot those 32 lasers very, very fast to generate 700,000 measurements per second. So, mounting this on a UAV, you fly around, you get 700,000 points per second. The lasers are oriented in a vertical array, assuming you have mounted the sensor like that. So you have 32 lasers on top of each other with a 40 degree vertical field of view, and it spins around 360 degrees up to 20 times per second. So you get a full 360 degree view and the 700,000 per second. It's relatively small. It's a size a little bit larger than a Coca-Cola can, and it only weighs 1 kilogram or 2.2 pounds, which is ideal for flying on UAVs, at least if you have a certain size of a UAV. Yeah, I think that's the main points there. The sensor can be mounted vertical. This would be ideal if you want to scan a building, like the stadium. You want to get the side of a stadium, but it can also be mounted in any orientation, so you can mount it in the horizontal if you want to look down, like typical aerial mapping is done. Velodyne itself, mentioning the word mapping, so far our biggest business, actually the most famous one, is the Google self-driving car, which uses a slightly larger version than that. But there's a big business on mobile mapping where people put these sensors on cars and drive around. Like companies like Nokia, Navtec, they have about 150 of these vehicles and drive around all over the world, similar to Street View, to map the world with cameras. But in the background, they take action for the environmental model. Okay, so that's the introduction. We are a little company. I'm from Germany. My name is Wolfgang. I have lived here for 12 years now. The company Velodyne is down in Morgan Hill, which is about an hour south from here in the direction of Gilroy. The concept was last year is Phoenix Aerial Systems. They have not moved on, but they have developed their system further. It was a proof of concept first. Now it's actually it's a real product. It's a second version. So the aerial light looks like in detail. You can see here. So a couple of changes in their concept. One is it's actually now a nice little square box. My pointer. A little square box. What's in IMU and data storage. That's a little black box here that the sensor is mounted to. And then you can use this box with the sensor attached to it and mount it to a UAV, to your UAV. That could be an octocopter, or in this case, it's actually a gasoline-powered helicopter. It can be all kinds of different UAV platforms that this system can be mounted to. And then, of course, in this case, it's mounted horizontal because the focus in this case was to look down. Phoenix Aerial System also has teamed up with a company called LiDAR America. The name is a little bit misleading because actually the main target market for LiDAR America is in South America, and this is where they're all present. And currently they're offering service flying of manned LiDAR systems, and the new offering will be to also offer services based on UAV LiDAR. And obviously here's the helicopter with the thing, and yeah. To show you a little bit of what that looks like when it's flying, this is a relatively new video and it hasn't been edited, so I apologize for the roughness of it. Turn that sound off. So the sound is working, I just turned it off because there's a lot of background speaking. It's, as I said, it's not edited. So you can see the helicopter there, you see the scanner in the front with the box with the IMU and GPS. And of course, the GPS and IMU is important because the sensor itself takes relative data to the sensor. But you still need to know where the sensor is and how it's oriented to put the data that's been collected all together and generate a big point cloud that comes out of that. This is the one where it's actually taking off. And of course, this sounds a little bit like a lawnmower. But I guess it has the advantage of you can run it longer than just on batteries. And the pilot and the cameraman didn't really agree on where he's going to fly, so he's going to disappear into the sky, and I'm sure you have seen all of them flying. But I don't have the point cloud from this data yet. That will be next time. I want to introduce another company that has been using our sensor, integrated it. It's called Hethcoat Photonics. They're on the East Coast here in the United States. They're known for hyperspectral sensors. What hyperspectral sensors are is they basically analyze the lights with respect to wavelengths from the surface that it comes back from to make conclusions about what materials are in that surface. So this could be used for flying over an area where you might think there might be diamonds or gold, and you can establish certain chemicals in the ground or in the water that that are precursors or somehow related and might be indicative of having these minerals in the ground. And obviously diamonds and gold is just one example, but those kind of things. And as an optional offering, Headwall, which is a company that's 16 years old and a spin-out from Agilent, Hewlett-Packard, they have now an offering where they include our LiDAR device. And they have put it on this infinite JIP UAV platform, and this is what that looks like. So this is their setup. So here's the sensor. It's mounted on a rotational gimbal, which allows them to actually change the angle on command. So they can fly out with the sensor in the upright position, and then while flying, you can actually point it in the direction that you want to point it at, and also ensure that when you land again, it's not necessarily in the most exposed position, but it's upright again, so in case there is a rough landing that you actually don't damage any of the sensors. There's the hyperspectral camera here, there's our sensor, there's a GPS and IMU, and of course there's data storage. And what we scanned when we did our test flight there, what we scanned was, we put a couple of ladders on the ground here, and that you can see here, and some wooden boards, and then of course you have the natural features like the bush and the grasses. And what you see down here, that's the real-time LiDAR data that comes out of our sensor. So this is not georeference, this is not the nice point cloud that you want to get at the end. This is really the live data that comes out of that sensor in real time, the 700,000 points per second. And the lines you see, that's essentially each laser beam rotating on the bottom and making that reflection. You can clearly identify the ladder here. The boards are in this video, sorry, this slide are not that easy, but here you can see the this green strip that's here that has a different altitude. You see different features, and if you spend a little bit longer, you can actually recognize each of these features in that point, in that live image. So obviously you want to see the thing flying. The UAV manufacturer is up in Toronto, in Canada. Here again is the different components of the system. And here you see the target ladders, just to have some structure in the picture to see what it looks like, what can be scanned. Now is that rotation. The scanner is being moved from the vertical position to the horizontal position to look down. So this is what the test range looks like. And of course the live data out of our viewing program. It's a little bit dark here. Because that's not ideal, there's a room that has a lot of light. You can see the ladder here while you fly over it. As I said, this is the non-georeference data, this is the live data. Of course, if you store all of that and put it in one big point cloud, you get an excellent model. You can take measurements on how wide the ladder is, how tall it is, how much it sticks it out. The accuracy of our sensor is about plus minus 2 centimeters. And then, of course, in addition, you have the accuracy of the GPS. So you end up with about 5 centimeters accuracy. And then for landing, as I said, it's floating back to the horizontal position, so that worst case, the landing is rough, the sensor is being damaged. Yeah. Another company I want to mention, this is, we're not just selling systems here in the United States or in South America. Another company is Robotics. It's a company out of Germany that makes hexacopters. And they actually recently have been purchased by the mother company of Leica Geosystems, which Leica is one of these companies that makes the systems that's outside to measure construction sites or mining areas. And I'm sure that's where their main target area is, to sell this to mining customers. So instead of having airborne LiDAR, they can do this on a daily basis, fly around their stockpile, measure volumes, or look how deep the hole is that they dug on that day, where they got the minerals out of the ground. And they have integrated our 32, and here's the video of their promotional video. In all true confession, not all of the data you see in there is actually made, sorry, not all of the data in that that's in this video is actually been done with exactly that configuration. They took a little bit of a marketing license, but it's still very impressive. Obviously, their claim to fame is this special construction of the frame, so that you, when you hit a wall or something, you don't break your propellers. Also, from a safety point of view, it's a little bit more difficult to get a finger into the propeller. It's mounted on a gimbal. In this case, the gimbal was fixed, but there's no reason to have the gimbal not moving it in a, from any position, vertical to any horizontal position. for example, this data, it says create indoor models. Obviously, if you do create indoor models, you have to think about the GPS. IMU still works, but GPS doesn't work, so you have to do something about that. So I don't think that actually has been really realized. That's more of what they want to realize. But you can see power lines with our system when you fly on them, when you generate these point clouds. And even so, the data is taken from the top because it's a real 3D model. You can put your point of view anywhere. And if you add camera data, you could even add RGB data to it and make it almost look realistic, photorealistic. So I think. I think you're getting the idea. I mean, obviously, a lot of people say, "Why don't we use photogrammetry?" And I'm sure that's a way of doing some 3D data, and that's obviously a relatively inexpensive way of doing it. But I have to assume that when it comes to real measurements, where you really need to know where's your location within the centimeter range. If, for example, if you scan a factory or oil refinery, and you will really want to know how has it been built, because the blueprint might be completely different than what really is in reality out there, then photogrammetry at larger distances will not be as accurate as a LiDAR measurement that really does measure the distances. This is a company, Rootscene, in the UK. It's actually out of Scotland, and they developed something similar to what I talked about in the first company. So they have a LiDAR pod. Essentially, they make this little box on the bottom. It's using carbon fiber material to keep the weight low. They're mounting it on this Vulcan multi-frame, which is also a UK company, and doing the same thing, looking down, scanning the area, and I'm going to show a couple of pictures out of that. You can see the differential GPS antenna that's here. You see the one side, the other side is back here. Obviously, the higher accuracy you get on your position, on your GPS position, the higher accuracy you get in the absolute point cloud, the relative data will be fine. And see that one in action. There's no sound to this one until it takes off. So you see the pod here with the carbon fiber material. It's obviously done in the UK. If you look at the jackets, very typical for airfields in England and Scotland. There's the scanner scanning. So they kept the opening field very small, not to have anything influence the scanner. And then, of course, it takes off. Here's the differential GPS. I'm going to jump a little bit, as I'm sure you all have seen UAVs flying around. The interesting part is more what comes out of it here. Very nicely seen. The sensor obviously can be flown in any direction. Let me go a little bit forward because I think there's a section where we actually see the lens, and then you actually see the data, again, the real-time data, not the point cloud. So this is kind of done filming off the laptop, the real-time data playing right after the flight. So this is what the sensor sees. So here you see some colons. Here you see a car coming by. Or the car is probably stationary and the UAV was flying over it. And again, now if the data is all being compiled and georeferenced, you actually get a very nice point cloud. The last application I want to show is with exact maps. This is actually very interesting. That's kind of why I kept it to the end. Exact Maps doesn't use a GPS, it doesn't use an IMU, so therefore it is indoor mapping capable, and they're actually doing that right now. And they will be exhibiting at the AUVSI show, which is next week in Florida, in Orlando. And they also, one of the things they've implemented is not to store the data on board, but actually to have it completely wirelessly transmitted down. And it's about 2.5 to 3 megabytes per second. That's the amount of data. So it's similar to a high density video stream. And obviously they have a video as well. And to me, that's very impressive. This company didn't have a sensor less than 9 months ago, and this is what they realized. So here's a GoPro camera on there, and our sensor. This is a live view. And then in a second, you see the point cloud that is generated using something that's called a SLAM process, which is a self-localization and mapping. So essentially what it does, it looks into the data and recognizes features. And then from one shot to the next shot, it determines how did these features move. And that's the movement that the UAV did. And that's the movement that's being used to generate the point cloud. So it's a self-referencing process that doesn't require GPS and IVR. From my angle, this is very low. You see the power lines in here. It's obviously flying over a foresty area. And now you see a little bit of a city steam. And look at this advertisement here for a long time. You're going to see that in a second again. This is the live data, real-time data out of the sensor. And you see that it's a little bit brighter down here. But here you can actually see for a lifetime or whatever it said there, you can actually read that on the side of the wall. And that's because our sensor not only measures distances, it also measures reflectivity. So if there's a high contrast, you're actually being able to pick that up. Specifically, if there's retroreflectors like street signs or something like that, you can filter those out from diffuse reflectors, which are in nature. And that brings me to the end of my presentation. I will be here till this afternoon. If you should have questions that don't get answers after this talk, shoot me an email at lidar@velodyne.com, and I will answer you. But if there's questions right now, feel free.
What's SLAM mean again? SLM?
SLAM means self-localization and mapping. So it's a little bit like if you stand here and take a picture, a 360-degree picture, you take your camera, you point it in one direction, you point it in the next direction, in the third direction, and afterwards you want to put it together into one image with Photoshop. You kind of look into the picture and you see there's a tree on the right side. So in the next picture you want to have the same tree on the left side. And that's essentially what this is, much faster and a little bit more accurate in looking into 3D data rather than just doing it by hand in Photoshop. Yeah.
Morning.
Hi.
I'm curious, is anyone trying to, first of all, Stephen Riley from Swift Radio Planes. Is anyone trying to integrate your LiDAR into a fixed-wing airplane?
Yes.
Okay. What's the range of your LiDAR?
The range of our LiDAR is up to 80 meters. We do get signals at 100 meters, but the effective range where you can really still see features is about 80 meters, which of course means if you fly and you're looking down, you can fly to about 70 meters because you also want to see a little bit in the diagonal. Yes, that's the range.
And at the speed you're flying, well, if you were to fly at 18, 20 meters per second, is your LiDAR spinning fast enough?
Yes, so I'm missing that slide, but I can send you that if you send me an email. So if you take an area of 50 by 50 meters, that's the example that we calculated. If you have an area of 50 by 50 meters and you fly at about 20 meters per second, you get a point density of 80 points per square meters. Or in that whole area of 50 by 50 meters, it's 200,000 points in that field that are distributed there. So it's 400 sweeps, and in each sweep, going out about 20 degrees to each side, each sweep you have about 500 points, if I recall that correctly from memory.
I see. Sir, just one more thing. Your data storage. Okay. Sure.
Next, go ahead.
Real quick, from the mapping side, I work with folks like Wolfgang all the time, and one thing that you might want to mention, because people don't think about this, the system you have is extremely affordable, and if you go to SLAM processing and dump the IMU, it even gets more affordable. I don't know if you mentioned it, but you might want to mention what your price range is for that.
Yeah, so the price range, I mean, people know from the big companies that I mentioned that do surveying equipment outside, they're beyond the $100,000 point. Our system is around $40,000. So that's the sensor itself. If you do slamming, you don't need a GPS IMU. Otherwise, you need to add the cost for a GPS IMU. That's typically the precision that's required. That's not required in the sensor. So we really just do an OEM component, and specifically for this industry, where you have a lot of people that are very capable of putting systems together. I mean, all of you probably work in the garage in one way or the other. That's ideal. It's not a complete turnkey system. You need to add the georeferencing either with a GPS IMU or with a slamming process to get the full point cloud.
Hi, good morning. Two questions in one. How many rebounds did you get for each one of your beams?
Say that again.
When you shot, do you only get one rebound back, or you can get?
Currently, we only get one rebound back. But the question is, which is known as multiple echoes in the airborne LiDAR industry, we're working on that because I get the question all the time. In the mobile mapping in a city, that doesn't matter because laser beam hits a wall and it gets reflected. The question is, if it hits bushes or grass or some tree from the top, you might get a wrong signal from the top of the tree while you're really interested in the bottom of the ground. So now that we start going to the airborne systems, that is a topic, and we're working on the multiple returns. So probably in a month or two, we will have that.
Great. And the question of the other gentleman, storage. Does it come with onboard storage?
The system itself, it's just the sensor and the data comes out of it. So you would have to deal with storage or with wireless handling of the data. And as I said, I'm around till about early afternoon, so see me in the back and let me answer your questions.
Okay, we're going to take a little break, and instead of taking a 30-minute break, we're going to take a 15-minute break, so go talk to your fellow wizards, and we'll convene back here at about 11:20.
I'd have to restart it again to see what the delay is, but now I've paused it. So I've got a chair here.
Actually, can you go around? We got a lot of
Operator.
Excuse me.
All right, we got to do yours too. I'm sure, like all of us.
I just didn't want to presume still my equipment to break, you know. I was up there this morning too.
All right, everybody's got to start moving back to their seats. We're going to pick up the program. All right, everyone, we got to get back in our seats. Don't make me come back here with a cattle prod. Please take your seats. All right, in the back, we need to take our seats. All right, I'm coming out there. Okay, we're going to start the session again, and I've asked people to come and sit down. And in the back, the people in the booths, you're going to have to kind of keep it down some because people cannot hear that are trying to listen to the presentations. I don't mind if you talk, but you got to kind of talk in your inside voice, as Mom used to say, so people in the back can hear the presentations. There's a lot of good information. You don't want to miss it. So please take your seats. After the next two speakers, we'll do a lunch break for an hour and a half, and you can talk to no, they don't listen. They're off in their own little world. I'm doing my own thing, man. Hear that foghorn. Okay. So like I said, after the next two guests, we're going to take a lunch, hour and a half. You'll have plenty of time to talk with everyone. So again, quiet in the back. You want to go back there one more time, guys, please? Tell people to sit down. And actually, if you don't want to sit down and you want to keep talking to whoever you're talking to, you can go outside, and then so the rest of the people can hear. If you want to do that, you got choices, options. Anyway, we're going to kick this back off, and our next presenter is Henri Seydoux. Is that good enough? Okay, my French is improving. And you are the CEO of Parrot Company. Please welcome Henri.
Yes, hello everybody. So I will present you why we do drones at Parrot and how all of this happen at Parrot. So frankly speaking, I am not an engineer, I am an entrepreneur, and the ideas really they come from the time when I was a child. When I was a child, I was very good for paper planes, and also I like very much very small planes with elastics, and also kites. I was fine. I learned how to do and to fly the kites, and to build the kites, and also I had a very simple planes that you run with a cord. So I did not know, but my inspiration and the inspiration of the company doing those robotic devices really come from this. The first project we started at Parrot was called BTT. So Parrot is a company that I started 20 years ago, high-tech company, and the name of Parrot do not come from the fact that we do drones, but it comes by the fact that we do speech recognition and we do consumer products using speech recognition, and we are more DSP, software specialist, speech processing specialist, and audio specialist. And we have developed a lot of Bluetooth products. Especially, we do Bluetooth products for the car and the car industry. So 10 years ago, I was thinking of what next in Bluetooth. What can I do next in Bluetooth? And the project was called Bluetooth Toy, BTT. So the inspiration, the ideas, they come from the childhood, but also from the technology. When the Bluetooth system, this is an early Bluetooth system, who was a digital radio the size of a match. 10 years ago, it was incredible. You know, when I was seeing this, I was thinking, it's incredible. I can do something with it. You know, if an electronic radio digital cost, at this time it was costing a few $5. I was thinking, if I have this kind of radio, I can really do something new. And also the cameras. This is a consumer video camera that is used in a webcam or used on a phone. And when I have seen this, I am completely amazed, because this is a full camera. It takes video in color. It has a lens. You have a white balance. It's not the best camera, but it is a camera. So I was thinking that it's certainly possible to make toys with Bluetooth and video cameras. So this is how we did the BTT product. This is the early BTT. So the early BTT was a remote controlled Bluetooth car with a video camera. And this product has never been launched. This product has never been launched 10 years ago, and I think today people are launching this kind of products, but because it was not possible to launch it. The counterpart of this product, what I was thinking, was to use this Nokia cell phone designed to be a game console as a cell phone. It was very innovative, but this product was a failure, and one of the reasons was because it was not really possible to put apps in this telephone. You can put some video games, but not deeply use the phone hardware and the phone technology like Bluetooth to make innovative products. So, and also, as you have seen, we made this car, we made this toy, but it was not so great. You know, a car is not so funny. I don't have my driver license, I don't drive, but I know that you cannot have enough fun with those things. So I look for something else. I went to Sony, and at this time I get the idea to make something working with PSP, which was a very good hardware, very capable hardware, but there is no Bluetooth in this console, so it was not possible to do something. So this project, the BTT project, was more or less dead. So I had to stop it. And I heard about a quadricopter. This is an early quadricopter. This is a quadricopter for 1905, quadricopter from Louis Breguet. And as you can see on the picture, it flies. But it's not possible to control it. It was a thing to be controlled by a human person, a pilot. And this kind of flying devices are too unstable to make them fly as an helicopter. This is why they did not succeed as an helicopter, because it was the first idea to make a vertical lift helicopter. So I heard about this one. You can, if you look, you can find older one, older solution on the principle of the quadricopter. So my project of toy was impossible. I heard about those old quadricopters, so I decided to do a Wi-Fi quadricopter. So the other source of inspiration of what we do at Parrot is consumer devices, consumer products. We do, as I told you, we do a Bluetooth system for the car industry. For example, this is the Tesla. We do the Bluetooth and the Wi-Fi system for the Tesla. For many Audis, BMWs, Volkswagen, Japanese car, the system comes from Parrot. And we do also a very nice audio system running on Wi-Fi or on Bluetooth with a very mature DSP software. We are DSP engineering people. Speech processing, and which is also a very complex technology. When you have to remove the noise on the speech inside the car, is nearly as difficult as, or is as difficult as making flying a few hundred grams device in the wind. It's a very technical company. So to our drones, we take the same idea of, and the only thing we know, so what we know from consumer electronic, especially Linux. Everything we do recently, but every drone that Parrot has done runs on Linux, and it is the biggest part of the biggest technology component on our drone is Linux, but also ARM processor, Wi-Fi, the App Store in Apple, or the Play Store in Android, which is a free system developed and developed worldwide that permits you to update your devices anywhere. It's something incredible if you think about what offers the App Store for free for developers. You can have devices anywhere on the planet, and you can upgrade for free without deploying any computer system the software. And we discover the MEMS. We are not working on MEMS. We do not use MEMS on our product, but we discover the MEMS. So we start with the InventSense gyros at the beginning. And also we had a lot to learn about aeronautics. So I hire a very nice engineer, François Calou, who was designing military devices, and we start to create a startup inside the company and to develop this new project, where you have to understand that and everybody in the company was against me in a certain way. Why I was thinking of doing toys for the cell phones and with no business case, with no clear idea of how to sell them and what to do with them. During 1 or 2 years, we start and we work, and at this time we found no open source code for the autopilot. We found only publications on the various universities in Europe and in the US. Finally, in 2007, we get a business case, which is the iPhone. A business case that I did not really like at the beginning, because I was not looking as a telephone, you know. I was looking as a gaming device with some capability, but that I have nothing. And finally, Apple launched the iPhone in 2007, and nearly 1 year after, they opened the iPhone to develop apps. And this was quite new. So we had our internal development, and we move our internal development to be compatible with iPhone. So, but the main idea was coming years and years before that the iPhone reached the market. So we launched the AR.Drone 2.1. The AR.Drone 2.1 was designed to, 1.0, sorry. The AR.Drone 1.0 was designed for indoor. Also, it was mainly designed for indoor. It has no GPS. It has a way to measure the speed on the air, but without the GPS. We understand that we have to do it for outdoor, so we make a removable hull where you can have it indoor and outdoor, and a very simple hardware. A simple hardware. Simple doesn't mean it is not complex, because this hardware on a certain way is still more sophisticated than most of the drones that fly today. For example, like a mouse, this hardware measures the speed of the drone with a vertical camera, and he do optical flow to be very easy to pilot indoor. Because what I want is the fact that a kid can buy it and branch the battery, press the button take off, and the thing take off, without understanding nothing about what is flying, what is physics of flying, what skill do you need. So for this, it's very difficult in indoor to have something that is steady at the first time. And the only way we find is to put those vertical cameras and those ultrasonic sensors that are in fact also very useful. So 2 years after, we did the drone 2.0. So the drone 2.0 is better suited to fly outdoor. It's even more simple. It has only one board. It has a full HD camera, and you have to understand that all the drones have been designed to be toys. And in fact, we discover that they are much more than toys. They are much more interesting than toys, and also they are much more. We develop much more technology that needed only for toys. We develop a lot of function for the drones, including, for example, a cloud system where you can store all your data for your flight. The fact that you can upgrade all the software for each microcontroller in the drone using the App Store. So a very simple. The success was great. We have sold nearly. I think we have communicated that we have sold more than 600,000 of those two drones, and but the success was really more than expected. And after doing this, after doing the drone as a toy, of course, I understood that the drone as a toy, the drone is much better than a toy, and the drone is frankly, the success of the AR.Drone, and it was not designed for this, was the tens of thousands of videos that have been posted by users on YouTube. I think there are nearly 40,000 videos done by drone users, AR.Drone Parrot users on YouTube. So what people want is a flying video camera. So now we really understand this. Really good flying video camera. This is what the people do. But also, we invest and we find a very nice team in a very good university in Europe, which is École Polytechnique de Lausanne, who were developing drones and professional drones, very simple professional drones, very close to what we did when we do professional drones as a toy, with a technical inspiration very close to what we do, but for example, where anybody can learn how to use it. To use an EB, of course there is a training, but you can really learn how to use an EB in 10 minutes. You just how the software is designed, how you fly the device, how light is the device, and it's really something as simple as you. It's more simple to use than a bicycle, for example, or for some things that you need a lot of training, you know. So this is the EB, and also, for example, the EB, the main software is on the tablet. You can download everything through the tablet, and so this is I think the drone as a toy as an inspiration for drones, and the consumer electronic product is really an inspiration we like to follow. Of course, the usage is very different. The EB come with Pix4D software, and this software permit you to make 3D maps with accuracy of 5 centimeters in a few hours. I don't know if you have seen the demos of what is done by the EB, but the EB is certainly the leader, the most widely sold professional drone for mapping. I think now we have sold hundreds. We have sold hundreds with the software, because the EB come like a consumer product with the drone and the software, and it's a turnkey solution. We also, of course, work a lot on agriculture, and we are launching the EB agriculture version those days. EB agriculture come also with a software package from Pix4D, which is also a Parrot company. And so the EB is really a very simple device. So this is the story of the drone at Parrot, but finally we did a toy. So because learning a lot from doing drones, we understand how to do really a toy. So we did this toy that we are launching in a few weeks from now. Thank you very much. You want me to take questions, or okay? Well, if you have questions, go ahead. Okay. No questions, so it was so very clear. Thank you very much.
We're whipping through this. Okay, well, that was Henri. That was a good presentation. Our next presenter is Doug Marshall from New Mexico State University Physical Science Laboratory. I know Doug for a long time now. We first met on the ARC, on the small UAS ARC, and Doug was one of those lucky individuals that got to hear me complain for about 10 months straight. You lucky guy, you. Anyway, would everyone please welcome Mr. Doug Marshall.
Well, good morning. Patrick, thank you for inviting me to address this group. Quite a crowd here. When Patrick asked me to attend this event and talk about what we're doing in New Mexico State, I was a little surprised actually, because I'm not directly involved with the day-to-day operations at our flight test center. I thought he'd be asking me to talk about privacy and regulations and legal issues, what I'm usually doing, but I'm proud to stand up here and tell you today about what I know about our test center. Just with a show of hands, can I ask who of you are aware, in fact, that there is a flight test center in southern New Mexico for UASs? That's better than I expected, actually. Okay. It's ironic, as I was standing out here at the break, I got an email from a colleague and a friend who was pretty distressed over having just been told by a military installation where he had, for over 5 or 6 months, had planned a test of some system or some payload that they were going to take to this particular location, and told them that they couldn't do that anymore, that there had been a change in policy, that the DoD was not going to allow civilian or civil UAS operators or developers or researchers to use military installations for their research. And he was not aware of this change in policy and was looking for some guidance on that. And what I emailing back to him was, well, first of all, I'll send you the memo because I got it a few weeks ago, but more importantly, I thought that he knew that there was, in fact, a flight test center available that did not require access to a restricted area to a military airbase, and he apparently was not. So, about 7 years ago, the FAA, believe it or not, in responding to increasing pressure from this community and from developers and folks like Patrick and others out in the industry for a place to be able to go out and test and do what they needed to do to get these systems, whether they were payloads or the airframes themselves or the power plants, in a position where they could be safely flown or even begin to go through the airworthiness certification process, decided to stand up a flight test center. And they chose New Mexico State to do that. Why a test center? You know, all the challenges that go along with flying UASs are well known to this crowd. Private industry needed a place to be able to do this without having to go to the military and seek permission for access to restricted areas. And the systems then, and I think in my opinion, still are somewhat immature and certainly cannot comply with Part 91 and the other operational standards and airworthiness requirements that manned aviation does. So why New Mexico State? They had a long history of operations with unmanned systems. It goes back way beyond before 2007. They have in place standard operating procedures, other processes and policies that for doing this kind of research and development. The location in southern New Mexico, which I'll show you on a graph here in a moment, as somebody said, it's not the end of the world, but you can see it from there. Las Cruces is where it's based. Las Cruces Airport is about 40 miles northwest of El Paso. It's pretty far out there. It's near the Mexican border, and there's a lot of airspace and a lot of land to go out and fly these systems without intruding on anybody's privacy or creating a hazard to persons or property on the ground. So how they go about it, they entered into a contract or a cooperative research and development agreement between actually the tech center in Atlantic City and New Mexico State University that basically created a long-term contractual arrangement which required certain operational procedures and policies to be put in place, and that the data, the operational data that was collected from the flights that would take place in the range or in the test center would be shared with the FAA, would be protected for proprietary reasons and wouldn't be accessible to potential competitors. But the FAA then and still is in a position of having inadequate data, safety data, to be able to fully assess the risks and the safety issues that are inherent in this technology. So the idea was to have a place for folks like you and this group and others like you to fly unencumbered, unimpeded, with minimal risk and the exchange being that the flight data and the safety data that was collected would be shared with the FAA for analysis. So the Flight Test Center is relevant to all classes of UAS. It's an FAA-approved process for assessing systems capabilities from the airframe itself through the payloads, communications, and all the other aspects of UAS operations. That's one graph, and I'll show you another in a minute, of the airspace. It's approximately 15,000 square miles of land that is encompassed within this test range or test center, with half a dozen or more airports that are part of the process of the system. We're next to the White Sands Missile Range core airspace and the White Sands Missile Range call-up area. So all flights and all operations within the test area are coordinated with either White Sands or with the Air Force bases that are located nearby. So a lot of land out there. There isn't anything out there except jackrabbits, scorpions, rattlesnakes, and the occasional coyote. It's a great place to fly and to test. There's 300 plus days a year of VFR weather. There's a varied terrain around the area. The Oregon Mountains are just east of Las Cruces, another mountain range to the west. So it's a great place to go fly, and that was recognized by the FAA early on. Physical Science Lab at New Mexico State University has been in business for a long time. The history of the university and the federal government goes way back to the dawn of the nuclear age. The Trinity test site, the first atomic bomb, was tested just up north of where we are in the Socorro area. We have engineering capabilities. The Flight Test Center itself has an infrastructure and a staff standing by and ready, willing, and able to assist. There have been numerous demonstrations that have gone on there over the years, some from the DoD, but some more often from the civilian community. Human factors research into design of control stations and even the human-machine interface issues that are also looked at, and then regulatory challenges. We've done a fair amount of work and gap analysis looking at the regulatory environment as it exists now and how UASs can be merged into or molded into that process. Doug Davis, who spoke here a couple of hours ago, was actually instrumental in the creation of this test center when he was at the FAA, and then when he left the FAA, moved on to another employer, then ended up at New Mexico State, was my boss for a period of time, and he just left recently. So that's the test center again. It's basically the focus is integration of UAS into the national airspace system, but it's not just a local issue, it's not just the UAS, but it's global. I don't want to read all this to you. I want to stand between you and lunch, but I understand that these presentations will be available to everybody either on a CD or DVD or through the internet, so you can take a look at them. But basically, we've been looking at civil UAS applications. A program that I was involved with personally last year and again this year was a night vision study conducted under the sponsorship of NASA and a human factors specialist on the New Mexico faculty, taking a look at visibility of UASs versus manned aircraft flying at night under visual conditions. And it's a really, really interesting study. And the bottom line was that the visibility of a small UAS and even a manned aircraft is better at night than it is at daytime. So the argument being made to the FAA is maybe we can come up with a process or a way to permit night flying, because a safety case can be made, or at least can be argued that it's in many respects is safer at night than it is at day. In fact, that study is about to be published in a journal right now. I just signed off on my review of it. The UAS testing and evaluation that is conducted, at least internally within the program, includes Aerostar A and B platforms, 100-pound payload capacity. So basically, the integration specialist can plug pretty much any system into the payload bay and make sure everything works and go fly it. So the idea is to leave a test bed or a platform for developers such as yourself with payloads to come in and test, or even bring the full aircraft down for airworthiness testing. civil applications, I mean, you're all very familiar with what's going on with that. One that came up, we were talking about it at the break, a local happenstance in northern New Mexico, up northwest of Albuquerque. A researcher from one of the other New Mexico universities, as an archaeologist actually, was using a small UAS to map or do a survey of some land way out in the middle of nowhere. If anybody's ever been to Chaco Canyon and looked at the ruins or the site there, it's an 11,000-year-old archaeological site, just a magnificent place to go. It's really chilling if you actually go out and walk around and look at this place to understand what happened there and who was there and how long ago they were there. And this gentleman found another site south of Chaco Canyon by flying a UA over an area mapping. Wasn't really looking specifically for that, but was able to identify with some fairly sophisticated imaging techniques and technologies the patterns of diggings and ruins and structures, ancient structures underneath, buried under the sand. And so they have found an ancient site that nobody even knew existed 6 months ago. It's really cool. So it's, and the UA was part of that. And unfortunately, from what I read about it, the individual didn't know that he needed a COA or anything like that to go out on that or not. One of the processes that was contemplated in creating this this test center was for airworthiness certification provisions. The airworthiness process that has been created in cooperation between New Mexico State and the FAA has been approved by the FAA and migrated to or implemented by the other test sites. You've probably read or heard about the stand-up of the other 6 test sites that were just created by congressional mandate. North Dakota went live, I think, 2 weeks ago. I'm not sure they've flown their first flight yet. Alaska got their COA on Monday and flew within an hour of their first operation. So 2 of the 6 test sites have now at least made a step towards actually doing some of this kind of testing that was called for in the mandate. We've been doing it for 7 or 8 years now in New Mexico. So the experience and expertise is 16 years of operating UASs in the NAS, special use airspace experts, and that should read NASA High Altitude Ballooning Program. This is actually based out of Palestine, Texas, but it's operated through the PSL organization. These are huge high altitude balloons that are flown out of Antarctica primarily, but other places as well. By the time they're fully inflated, they'd fill up a football stadium. They're just massive structures. They carry 8,000-pound payloads, do circumpolar flights around Antarctica or around the North Pole. And they drop their payload when it's done by parachute and it's recovered. It's an amazing process. And we've been doing that for 20 years, so we have a lot of experience in dealing with special use airspace issues and putting large, unnavigable or unsteerable structures like high altitude balloons into the atmosphere. UAS operations are routinely conducted in the NAS. Like I said, we have the Aerostar A and B, an Aerolite, an Orbiter, other smaller platforms and trainers. We work with the DoD on a variety of other UAS-related functions. Bottom line is developing and validated civil UAS mission sets for the FAA. That's why we're there, we exist. The airports that are available, Las Cruces is where we're based. We have a nice big hangar there with all the assets and resources there, with test beds for engine testing and autopilot test cells as well. Lordsburg and Deming are just west of Las Cruces. Socorro's up north. Grant County is near Silver City, if you've ever been there, Grant County Airport, and Truth or Consequences, and Playa. So these are the main airports, and there's a half a dozen other strips. The Jornada strip that's mentioned here is out on this large plot of land that's actually managed by USDA. And they do regular flights out there looking at the foliage and the flora and fauna that live out there for research purposes. And they've been flying UAS as part of that research effort for several years. Again, this is all coordinated with the military. And then last time I was out there actually for the night vision testing, we, real nice quiet evening. We were waiting for the light to change to go from dusk to night. Keeping our eyes out for other aircraft, but really not hearing anything. And then somebody heard a buzzing. We looked up, and it was a Predator going over, probably at 18,000 feet. on a training mission from Holloman. But it was the only other airplane in the airspace. It was way up above us, and it was unmanned. It was really neat. So how can we help? We can assist developers and researchers in determining the specific requirements that are there to meet the operational needs. And for those who are going to pursue airworthiness certificates sometime in the future, or at least apply for a COA, we can provide expertise in that area, provide crew training and certification, establish airworthiness and other criteria for introduction of UAS systems into the NAS, and evaluating all other kinds of systems, whether it's payloads, communication systems, the airframes themselves, or the power plants. The New Mexico State team and staff and executives have been involved with the UAS development virtually from the beginning, from Access 5 right up through the current time. You've heard all this, FAA's UAS and the NAS effort. Jim Williams is going to talk about that after lunch, I guess. The bottom line is safety of flight, compliance with FAA regulations and policy, and creating a space for the civil market and civil developers to fly and to operate and develop your technology. Just some photographs of some of the things that are going on. You know about all this stuff, so I'm going to slide through it. Bottom line, safety of flight, and that's why the Flight Test Center was set up, to allow developers, operators, scientists, anybody else that has an interest in developing this technology to have a safe place to fly under a set of policy and set of procedures that is covered by a COA. I mean, it's there for the taking. There is a cost that's attendant to it. I can't tell you what it is because it's just cost-based. We're not allowed to earn a profit as a public university, so whatever resources and assets we have to put out there to assist you is what you would be charged. And I'm not the person to talk to about that, but I'll be happy to put you in contact with those that are. And that's the guy. Dennis Ackland's currently in charge of the Flight Test Center. If you have an interest in doing this, or you're looking for a place to fly your systems, we've been in business for almost 8 years now, so he's the man to talk to. Be happy to entertain any questions. If not, you can go to lunch, I guess. Got a question here? Sure.
All right. Hey, my name is Bo Pollitt. I'm with Aurora Flight Sciences. We operate out of the test center in Virginia. And I noticed that all of these different test sites are kind of coming in their own different speeds and different kind of philosophies behind each one. I was wondering if you could just speak for a quick moment about what makes your site different from the other 5.
Great question. We were there first. We were there before there was a congressional mandate that required the others to be set up. I think that the others are going to be following these standard operating procedures and policies that were created in cooperation between New Mexico State and the FAA. Probably the most outstanding characteristic is just the sheer size of the area that we can operate in. You know, that's a lot of airspace, 15,000 square miles. The other test sites and centers that I'm aware of are multi-party. There's a lot of people that are involved, a lot of developers, a lot of different elements of those. And I'm not real sure. I'm not convinced that they've all figured out yet how they're going to manage these large organizations that have been created to respond to that opportunity. You know, all I can say is just experience. We've been there for a while. We've had people and staff on site that have been doing this for a long time. So I can't speak to the other sites. I don't know what they're doing other than what they put out in the press releases. Anything else? 5 minutes over. All right, thank you.
Yeah, for people that haven't been down there, I actually went to their facility. Doug gave me the tour, Doug Davis, when I was down there doing some work for the Army at White Sands. They have a really nice facility, hangars, aircraft, chase aircraft, and plus you're right next door to kind of the birthplace of American spaceflight. If you ever get a chance, I'd suggest you go down there and tour the facility. All right, well, we're through half of the first day here, kind of, and now it's lunchtime. There are sandwiches in the other room. The soft drinks have not arrived yet. They're in transit, stuck in traffic somewhere. But we have about an hour and a half to talk and network and eat lunch. So we'll reconvene at 1:30. Thank you. I already talked. Oh, dude, I'll be there in a half hour. Oh, dude, I'll be there. I'll be there in 10 minutes.
Oh, that one, yeah. You can play that. I mean, unless you want to do This is like this is going I'm not sure why he grabbed this one. So you click onto the next one. And you just go. This is the one that was this is yeah. So then you go to the next one. Because there wasn't it's there.
Right.
I'm assuming not easy. I haven't used this equipment, so I'm not going to do it. It should still be the same. It's just sometimes the different systems, but essentially it's supposed to work the same. Yeah, just in case. Yeah, you can just manually play the video. But let's just check this one because this is the Parrot side. Well, you don't have it set up for it.
Nobody noticed Skyrate's comic songs. Yeah.
I did just post an Instagram, but we just have to sorry.
Yeah. Oh. And then, like, somebody gets up there, like, a little housekeeping. So it's more like, yeah. And actually, that person's going to get buried. They call them, like, yeah. Oh, we want to open it all. Yeah, right. You guys may want to do. I know you do race gunner. You could sell this number. Andrew, you should check out Jordan Close. You'll see the they're developing really elegant and then the next one. They're doing hard. They're doing hard. And then we just get the that's part They're not partners. They're one of the Kilo. Yeah, Kilo. Yeah, they were. There was a similar one. Yeah, but that's on fire. And to express the idea, but really, I haven't told very well about it. You know, you have to like build something around it. You know, you're toxic. Yeah, and then people are like, get it. And he's like, people kept getting hung up on breaking that. So I had to go to sit down. Well, and I also got this nice talk with today. Really smart guy. He pointed out to me you know, so what I would do is make sure that you're figuring out what is the data. All of these are we talk about we demonstrate right. Yeah, that's everything is right. Right now, we just started like that's you guys find anybody else who want the problem with these interviews are
Hey, anybody who didn't get soft drinks or water, go there in the sandwich room. The soft drinks are here and the waters are here. Help yourself.
I know that, I just got back from What did you do? You're like, what, yeah, but we always say it's fine. Yeah, yeah, she got like the suit. Yeah, I think I don't see how you can just find it out. I mean, yeah. One of those terms, like, yeah, like usually instead of trying to be like, yeah, that's trying to be yeah. Everyone's like back
Right.
We need to start heading back to our seats because we're going to start at 1:30. So if you can start making your way back in the room, I would appreciate it very much.
Absolutely. I think the sound was turned down on that too.
After the presentation,
Okay. Well, you're the last speaker, right? Yeah, yeah. I mean, you just don't want to leave him on his computer?
I don't know, because usually some of the
Yeah, what we can do is he's going to post the...
because he's posting the videos.
All right, it's 1:30 on the dot, and I want to keep the program rolling, so please take your seats. And I'm going to ask that the exhibitors in the back please suspend conversation till after this presenter, or at least keep it very low, because I think everybody in this room has got something that they could probably learn or glean from our next guest. Our next guest is Mr. Jim Williams, and he is the manager of the FAA Unmanned Aircraft Integration Systems Office. Did I say no? Unmanned Aircraft Systems Integration Office. Yes, I think I got it correct. And he's actually the man that's helping trying to get us integrated into the airspace. He'd asked for extra time so he could answer questions from the audience. So he's going to do a Q&A after his presentation. We'll have plenty of time to ask questions. Some folks might be a little frustrated. but we got to be respectful and have intellectual and educated conversation. So without any further ado, please welcome Mr. Jim Williams.
Hello, everyone. Can you hear me in the back? Usually my voice carries, so it's usually not a problem. I am really happy to be here. A lot of people have asked me, well, why would you go there? And I said, because this is a key portion of the industry, and the FAA has got to be responsive to the entire industry, and I'm really very much glad to be here. And for any of you people out there wondering, no, I was not punished to take this job. I volunteered for it. I've been at the FAA a very long time, done a lot of different things, and I saw that the FAA really needed some strong leadership in this area. And I've had a motto in my life: never complain about something you aren't willing to go fix yourself. So here I am. So today I'm going to focus a little bit on the risk. There's a lot of conversation in these type of conferences about the capabilities and what we can do with these vehicles. But from a regulator standpoint, I really want to remind you all about the fact that there is risk in this process. So let me begin by sharing several questions that must be considered. What are some of the main risks associated with unmanned aircraft systems, or UAS as we call them in the FAA? What are the potential consequences to opening our skies to UAS? What about the people on the ground? What kind of injuries or damage could be caused by one of these aircraft? More than you might think, even though they may weigh only a few pounds. Let's make sure. There we go. So let's begin by discussing an incident that occurred last fall during the running of the bulls in Virginia. Apparently the folks in Richmond really liked the spectacle of Pamplona, and they decided to duplicate it. It was done at the Virginia Motor Speedway, and this video is an unauthorized unmanned aircraft, which is a small open rotor hexacopter that was hired to film the event. So let me play the video for you. Okay, this is an apple. Where's the mouse?
That is the mouse.
Why? Yeah. No, I didn't get it. Ah, okay. Oops. Yeah, that was it.
I just crashed into the stand just now. GoPro, yeah, look, I'm like looking at it, I'm hitting some dude in the face. I was just like following it in the sky. I wasn't recording, I was oh my god, that was crazy. It hit him right in the face. Man. That was a little wicked.
Apples. Anyway, the rest of it just goes on them commenting about the people that were injured. So there's not really much additional information to be gained by playing to the end of it. The FAA investigated this incident and did determine the identity of the operator. When questioned, the operator believed that the crash was caused by a malfunctioning battery. Several people in the crowd sustained minor injuries as a result of the incident, but the potential for serious injury as a result of small manned aircraft is real. And unfortunately, this wasn't an isolated incident. During the Endure Batavia Triathlon in Australia earlier this year, an athlete was injured when a small UAS commissioned to film the event fell from the sky, hitting her in the head. So here's the video on that one. I am trainable.
A triathlete suffered head injuries after an unmanned aerial vehicle fell out of the sky, with the pilot claiming the drone had been hacked. As if you don't have enough on your plate when running, swimming and cycling 30-odd miles in the Australian sun, now you have to worry about drones falling on your head too. Triathlete Juchmann Ogden was competing in the Enduro Triathlon in Geraldton, Western Australia yesterday when she was injured by an unmanned aerial vehicle falling out of the sky. The
Notice that they
unfortunate
stole
triathlete
the
suffered
pictures
minor
from the
head
earlier one,
injuries
too.
requiring 3 stitches when the drone fell some 10 meters from above the course. The drone was operated by a local video company filming the race. In a dramatic twist, the drone's pilot, Warren Abrams, claims it had been channel hopped, or hacked, possibly by someone nearby with a mobile phone taking control away from the operator. Australia's aviation watchdog, the Civil Aviation Safety Authority, is investigating the incident. In Australia, drones in commercial use must stay 30 meters away from people. Meanwhile, in the U.S., a judge recently ruled that drones in American skies are perfectly legal, throwing out the Federal Aviation Authority's first and so far only fine for drone use. Amazon, Google, and Facebook are reportedly looking to drones for various uses, including delivering goods and extending internet access, not to mention the Cupid drone equipped with an 80,000 Volt stun gun.
So the Australians did investigate the incident, and they questioned the operator, who, by the way, had not been granted a license. In Australia, they have a system where you can get a license to operate an unmanned aircraft. He speculated, as I mentioned on there, that the crash was a result of numerous Wi-Fi devices in the area, causing interference with the system's command and control link. Well, as a result of the incident, as you can see, the competitor was unable to complete. She required several stitches to patch up her head. What's also interesting about this video is the narrator cites the recent NTSB administrative law judge's decision on the Raphael Perkert case and provides what is completely inaccurate assessment of what was going on there. I'll talk more about that later in my presentation. But let's just say that the media's reporting hasn't always been completely accurate or helpful on that case. For now, though, let's get back to discussing risk. So the risk from injury from unmanned aircraft is not limited to just people on the ground. Just a few weeks ago, a pilot reported a near mid-air collision close to the Tallahassee, Florida airport. An airline pilot reported what appeared to be a small, remotely piloted aircraft, similar to the one pictured here. I think he said it had a camouflage paint job was the only difference. He reported what appeared to be a small, remotely piloted aircraft at approximately 2,300 feet in the air. The airplane pilot said that the UAS was so close to his jet that he was sure he had collided with it. Thankfully, inspection to the airliner after landing found no damage. But this may not always be the case. The risk for a small UAS to be ingested into a passenger airline engine is very real. We all know that the Miracle on the Hudson aircraft was brought down by geese that went through the engines. Imagine a metal and plastic object, especially that big lithium battery, going into a high-speed turbine engine. The results could be catastrophic. This incident is just one of the reasons why it is incredibly important for detect and avoid standards to be developed and right-of-way rules to be obeyed. Most of the rules for manned aircraft apply to unmanned aircraft as well. But there are unique challenges that arise without an onboard pilot controlling the aircraft. Due to the communication linkages and human-pilot interaction, reaction times can be slower. Since there's no pilot on board the unmanned aircraft, see and avoid is not possible. Thus, the development of sophisticated detect and avoid systems is really critical. There are numerous what-ifs. It's important to develop solutions and answers to these questions before we risk the safety of the world's safest aviation system. One of the ways the FAA mitigates risk in the system is design and construction standards for aircraft. The incidents mentioned earlier in my briefing, point out exactly how important it is to have safety standards in place. These standards are currently under development and will be crucial to ensuring safe operation of all UAS. In the meantime, the FAA is working with ASTM International, a globally recognized leader in the development and delivery of international voluntary consensus standards, to create standards for small unmanned aircraft. And the 7 that are listed here on the slide. The initial release of these standards occurred early this year, and the FAA is in the process of evaluating these standards with the objective of recognizing them for use in certification of small unmanned aircraft. We believe that aircraft manufactured, operated, and maintained according to consensus standards will lower the risk for people and property on the ground. The process of creating and implementing standards is just one challenge. Safe, smart use of UAS is another. Safety is always the FAA's #1 priority. Small unmanned aircraft systems must not be operated carelessly or recklessly. So this is the perfect segue into a discussion about operational risk. As many of you know, in 2011, Raphael Perker operated a small UAS over the University of Virginia campus. He flew close to an active heliport, under a pedestrian bridge, and so close to one person that they had to leap out of the way. After a thorough investigation, the FAA assessed Mr. Perker with a $10,000 civil penalty for careless and reckless UAS operation. Mr. Perker appealed the proposed penalty to the National Transportation Safety Board. In March of this year, an NTSB administrative law judge ruled in Perker's favor. The FAA has since appealed that decision to the board, and the resolution is stayed pending the full NTSB's decision. So effectively what that means is nothing has changed from a legal standpoint, and the FAA continues to enforce the airspace rules on unmanned aircraft. So far you've seen some examples of what not to do. These incidents may have only caused minor injuries, but there is significant risk. This is why integration will be an incremental process. While the national airspace system is not risk-free, establishing UAS operating standards and regulations will be critical to ensure that risks are managed appropriately and incidents, such as the ones that I mentioned, remain few and far between. So what steps are being taken to counteract those risks? How can we begin safely integrating these unmanned aircraft systems into our skies? There are several actions we were taking, and we're already working toward implementing them. First, we anticipate the notice of proposed rulemaking for the small UAS rule will be released for public comment by the end of this year. The rulemaking process is a lengthy one. This is just the first step toward introducing UAS weighing less than 55 pounds into our skies. It's important to mention that until the small UAS rule is finalized, commercial operations are only authorized by the FAA on a case-by-case basis. Currently, this has only happened once, in the Arctic. However, there is potentially good news for certain operators. Work is underway to implement the provisions of Section 333 of the FAA Modernization and Reform Act of 2012. This will allow us to move forward with incremental UAS integration. This section of the Act can only be applied to specific, limited, low-risk uses in advance of the small UAS rule. I stress the word may as we are still evaluating this option and developing our internal processes. If we are going to leverage Section 333 for those low-risk operations, there will be economic benefits as we begin to address the pent-up demand for commercial UAS operations. Companies from 4 industries from the FAA have approached the FAA and are considering filing an exemption request, which would begin the process. These industries include precision agriculture, filmmaking, power line and pipeline inspections, and oil and gas flare stack inspections. Precision agriculture falls into 2 categories. Application of fertilizer and pesticides, and crop monitoring. In Japan, farmers have successfully used unmanned aircraft for precision agriculture for decades. Currently, more acres of Japanese farmland are being applicated by unmanned helicopters than manned aircraft on an acre-by-acre basis. So using unmanned aircraft can lower operating costs and has enabled Japanese farmers to apply exactly the right amount of fertilizer or pesticide. In addition, the small helicopters used for this purpose create the right amount of rotor wash that enables the pesticides to be applied to both the top and the underside of the leaves. In the U.S., large farms use manned aircraft for aerial application of chemicals. Historically, this is one of the highest risk forms of manned aviation. So using unmanned aircraft for precision agriculture may actually reduce the risk in the U.S. airspace. The film industry has a tremendous interest in using unmanned aircraft. Historically, filmmakers have hired helicopters and airplanes for overhead shots. This can get expensive and it is dangerous. It can create extra noise and wind on the set. But these issues could become irrelevant with the use of unmanned aircraft on closed sets. Has anyone here seen the James Bond movie Skyfall? Show of hands? Yeah, quite a few folks. Well, if you remember the motorcycle chase scenes that took place on top of the rooftop of the Grand Bazaar in Istanbul, Turkey, they were all shot using sophisticated unmanned aircraft. If you've seen the movie, and you've already seen just how spectacular the video captured by unmanned aircraft can be. But potential use is not all about economic benefits and getting the perfect shot for a film. There can be real safety benefits for using UAS for certain applications, specifically for operations that we call the 3Ds, work that is dangerous, dull, or dirty. Oil and gas flare stack inspection falls into this dangerous category. I don't know if any of you have ever been driving along the highway at night and near a refinery and seen these giant walls of flame coming out. Let's see. Okay, I'm not sure how to make the laser work. Yeah, anyway. Down here. Yeah, that would be bad. That would definitely be a high-risk adventure. So, use of unmanned aircraft in these situations can actually help reduce the risk to workers. It's currently they have to shut down the entire production line of either the oil processing facility or the oil collection facility in order to inspect these. So if they use an unmanned aircraft, they can save time and money and keep the poor guys that have to climb those things and inspect them visually safe. So workers can be more thorough in their work while remaining out of harm's way. For example, when lightning hits the power line, these big transmission lines that you see running around everywhere, when lightning hits one of those, they have to go out and inspect them to make sure that they weren't damaged. The catch is the damage is on top of the wire. So the only way they can do it is to get on a bucket or a ladder truck and get up there and take a look. But by using a UAS, they can see that power line from multiple angles. They don't have to use ladders, they don't have to use bucket trucks, and they don't have to fear electric shock, and the operator can be a safe distance away from the line. They can see the line in its entirety and analyze it using HD video. So we hope that by using Section 333 to authorize some of these types of operations will help us move the ball forward. And I want to be sure that it's clear that the operations we're talking about are specific, limited, low risk to people and property on the ground. This isn't going to be a open season on new way of doing business. Now I want to conclude by showing you one of our big successes in 2013, the first authorized commercial UAS flight. The flight of the Scan Eagle UAS took place in the Chukchi Sea in September with operations conducted by ConocoPhillips and In Situ. ConocoPhillips used the surplus military aircraft rules, which allowed the FAA to accept the military certification to give a type certificate to these Scan Eagle aircraft. There were 4 of them. We authorized these flights beyond visual line of sight due to the remote operating area and the safety procedures that were used during the mission. The FAA is tasked in the 2012 reauthorization law with integrating UAS in the Arctic on a permanent basis. This demonstration represents the first step toward accomplishing the goals set for us by Congress. While we're not quite there yet, we have additional demonstration flights planned for this summer. So here's my favorite video, which shows the first launch and first recovery flight in the Arctic Ocean. Oops. Okay, still need training. Always amazed me that the wings don't just come off. And this takes place while the ship is moving, and they communicate the ship's location to the UAS, and they have about a 99% reliability of the capture of those aircraft. It's amazing. So as you can see, the future is now. This is an incredibly safe time for aviation, but much work remains to be done. The uses for UAS are virtually limitless. FAA forecasts that we can expect approximately 7,500 small unmanned aircraft in our national airspace in the 5 years following implementation of the small UAS rule. As we enter these uncharted times, safety remains our #1 priority. The FAA must ensure the safety and efficiency of the entire airspace, including all aircraft, both manned and unmanned. The more risk we mitigate now, the safer we will be as we integrate this exciting new technology into our world and into our lives. Thanks. I'd like to point out that I use this by permission from the National Agricultural Aircraft Association. This was on the cover of their magazine last month. They're very concerned about running into unmanned aircraft. Go ahead, Patrick.
I have the first question. I was just wondering if I could get a personal exemption because I put on such a good show.
Sorry, Patrick.
Hi, Jim. Eric Andelin. I'm a former board member of the MAPS organization, and I just wanted to point out that you've done a great job working with us. We appreciate that. And you were talking about Section 333. Would you talk a little bit about the under 4.4 pound rule for the folks here?
Well, there is no under 4.4 pound rule. The way the law reads, everything 55 pounds and under is all lumped into one category. And because the way the law reads that defines unmanned aircraft as aircraft, basically Congress, forced us to apply, every rule in the book, basically to every aircraft of any size. They didn't create a floor. So, at this point, we don't have any justification to do anything different for 4 pounds or 40 pounds or, 55 pounds.
Thank you.
Hey, Pat Kirby. Thanks for coming. It was a great presentation. I really appreciate the lines of communication. I represent I have a film and video. I represent the film and video interest in UAV, and it's a really exciting time, and there's a lot of interest in it, and we're really hoping to resolve things and come up with the ban on commercial use. In this, it seems like it's a different animal because the hobbyists and the devices are out there, and the hobbyists have them, and it seems like they are trusted to be self-regulating, but those of us who are going to have insurance and have client supervision, so the privacy issues are taken care of, and so on and so forth, and we're going to have substantial investments in our crafts and stuff like that. We are not trusted to be self-regulating. And I agree that we need to come up with regulations, but I just want to know why it's not like, okay guys, there's new technologies here, and it's a new kind of a new era here, and we want to work with you guys and come up with safe and sane regulations going down the road, and we need your help with it instead of, okay, here's a bunch of new toys and you guys can't play with them until we figure it out. And we kind of like to see it the former way.
Well, and I'm completely with you. First, I need to bust the myth. The FAA does not have a ban on commercial UAS use. I just showed you we actually have approved, at least one aircraft. And actually, there's a whole bunch more aircraft approved that are going to be operating this summer, also up in the Arctic from both AeroVironment and.
Can I drop your name? Can I drop your name when I ask for an exemption?
Yeah, sure. Everybody else does. So, but the bottom line is we understand that the certification rules for large aircraft obviously are just impossible for a small quadcopter to meet. We understand that. But I really don't like people saying there's a ban, because the rules are there. You just got to comply with them. And there's actually a rule in the rule book, 2117, that says, hey, if these certification rules don't work for you, propose your own. We'll look at them, we'll work with you, we'll figure out a way to approve that aircraft. That is actually how all airships are approved today. There is no section in the FAA rulebook that says how you approve airships. There are some consensus industry standards that airship manufacturers bring into the FAA and get them certified. So, the bottom line is that there is a path forward. It isn't optimal. That's why we're working on the small UAS rule, because that's a much more reasonable and appropriate approach for small unmanned aircraft. But unfortunately, the regulatory process is very slow and deliberative. 7 to 10 years is typical for any significant rulemaking, and this one is considered significant by the Office of Management and Budget, which is their call to make. So, it's going to take time. It has taken time, and it's my mission, and now it's the mission of the FAA administrator to make this a top priority for the FAA. The small rule is on our strategic initiatives for the entire FAA. It can't get any more important to the FAA than it is today. So, we understand, we feel your pain, we want to make this move forward. That's why we're, in the interim between now and when that rule is out, we're trying to do what we can under Section 333, and the filming industry is leading the way. So the way that process will work is the operator will come in and say, hey, we've got the following safety procedures, and they're going to be based on the MPAA procedures for using manned aircraft. And they say, we believe that we follow these procedures, we shouldn't have to get an airworthiness certificate for our aircraft. So that'll get published in the Federal Register. We'll take comments on it. If it's all approved, then the next company that comes in will be able to duplicate that exemption request exactly, and then it won't have to get published. It'll go through in a few weeks. So the idea is that in these specific industries where you have a very safe, controlled environment, like a closed set for filming, with professional pilots and, like you said, the people who we should be trusting. So we're trying to use Section 333 to do exactly what you suggest, which is in the area where we can trust people and we should trust them because of history and their professionalism. We're going to find a way to do that. Thank you.
Hey Jim, this is Jack Nickus with the Wall Street Journal. So I've spoken to dozens of people, I would say drone users over the past several months, including several here today who clearly are operating drones commercially without the authority of the FAA, which I suppose would be in violation of FAA policy. So with that said, how would you rate your effectiveness in enforcing your FAA policy over the past several years? And if you feel like there have been some holes and it's been ineffective, what does that tell you going forward about an enforcement strategy when you do have a final rule? Can you have inspectors on each street corner watching for a small UAS?
Well, obviously the FAA is never going to have an inspector on every street corner, just like we don't have an inspector for every air carrier airplane. The FAA's approach to enforcement is that when we are made aware of an unsafe aircraft operation, be it manned or unmanned, we investigate. If we determine that, yes, there was an unsafe operation, then we communicate that to the pilot or operator. Normally, once they understand that what they were doing wasn't safe and was outside of the FAA rules, they stop, and it ends there. If they don't, or they're not, they tell us that they're going to keep going, then we'll send them a formal letter that says, hey, you're outside of the FAA's rules. You shouldn't be doing that. Please stop. And again, if they don't, then, and there's another incident of careless and reckless, like Mr. Parker and some of the other, there's others examples, then we will go down the formal civil penalty route. I think, in reality, if you look at the potential damage, I'm sure the 5 people that were injured at the running of the bulls would probably, who knows, they may have had civil action against the operator, and that could be much more effective deterrent than anything the FAA could do. But the bottom line is, what we always do is, when we were made aware of an unsafe condition, we have an inspector investigate it. If they determine, yes, indeed, that was an unsafe operation of an aircraft, then we follow that step-by-step process to hopefully, bring people in compliance. Because the objective is compliance, not enforcement. So there may not be a tremendous number of enforcements out there, but there is a lot of work going on in the community to try to get people in compliance.
Okay, thank you for that. I just want to clarify. So you make specific unsafe operation. That's different than commercial operation? If there's someone who is flying under 400 feet in line of sight away from an airport, etc., but someone's paying them to do it, is that an unsafe operation, or is that in compliance with FAA policy?
Well, if you look at the rule book, the entire FAA rule book has multiple different categories of approvals, from little or no to very, very strict. If you look at the rationale behind that, the ones that are very, very strict are in the commercial world. Because it's been proven over time that individuals doing aviation work for hire, for compensation, are willing to take more risks than those doing it for their own personal enjoyment. So the rule book is set up that way. And now, granted, that's not always the case, but that's why the rules are the way they are. That's the logic behind it. Right or wrong, that's the way they are, and we have to enforce them. So the reason, the whole misunderstanding around operating of aircraft for commercial purposes is basically started around the exemption in Section 333 of our legislation, where special privileges were granted in law to modelers and hobbyists. So legally, those special provisions, special permissions, only apply when you're doing hobby or recreational purposes. Now, a lot of people want to stretch that definition and work in the gray area, and good luck to them. But the bottom line is, if you're getting compensated for your flight, just like if I owned an airplane and I was having people pay me to take them somewhere, I could not operate under the private pilot rules. I'd have to operate on the commercial pilot rules. So that's the rule book. That's what the rules say.
Okay, so commercial, I'm sorry, I don't want to take up a lot of time, just want to clarify. So commercial is, as you said, doesn't have an exemption in the FAA law, the FAA 2012 Modernization Act. But you investigate unsafe actions, which doesn't necessarily mean commercial.
Well, on occasion, we've been informed of operations where an individual is doing commercial operations, usually by a manned aircraft operation where they do manned aircraft surveying, and they'll let us know that, hey, I'm losing all my business to these guys. They're not approved. Go investigate. We will investigate those as well.
Okay. Thank you, Jim.
Hi, Jim. Thank you so much for your time. My name is Daryl Berkey, and I'm from Pro UAV Australia. I was very disappointed to see that example that you had in your presentation from Western Australia. We do have regulation, and we do have education, and you see the results. Okay, that person was not regulated. Okay, so you can't regulate common sense. People have looked at the rest of his videos, and the man is an idiot, and he's a danger to the public. Now, people who fly professionally aren't going to be. So I really don't understand this concept where, on the one hand, you can say the FAA is about safety, public safety, yet on the other hand, you're saying the only people you're stopping from flying, or who are being stopped, you're not stopping them, are the responsible professionals. So you've got hundreds of thousands of people out there who have no idea what the regulations are or what safety protocols are. Nothing's being done about them, like trapping, But here's responsible. Do you want to have insurance? Do you want to be regulated? And they have no way to do it. So I don't understand that. I'll also say about that video, the pilot in that video claims that that woman tripped and he did not hit her. So you'll want to be careful about that, because you'll be as bad as the media if you just generate misinformation. We don't know what happened there. It's being investigated. It was not a good thing at all to have in that presentation. But my main concern is, why isn't there an avenue for the responsible people to fly and to make a living and have a business, when you could just say, well, I'm not charging for this, I'm charging for the advice. And that's what a lot of people are doing. They go fly anyway, they don't charge for the flying, and they charge you for the advice. So it's a game. If you're about safety, why don't you get serious and come up with some regulations that support that?
Well, we are very serious, and we're doing, like I said, it's a #1 priority of the FAA to get those regulations out. The process has been, the regulatory process has been, over the years, Congress has passed many laws that require many different analyses to be conducted before they'll allow a rule to go into effect. This is to protect the public from over-regulation. So it slows down the process. There are a lot of people involved along the way who can all hold up their hand and say, no, we don't agree with your analysis, you got to go back and redo it. I know it sounds like I'm making excuses, but I'm really not. That's the process we have to work with, and that's why it takes so long to get regulations out.
Well, Congress has asked you to complete that work by 2015, and your statement.
But Congress didn't exempt me from the laws that they themselves had passed that govern the regulatory process.
Okay. So you're in between a rock and a hard place.
Yes, sir. And trust me, it is my #1 priority. It has been since I took this job 2 years ago, and I spend an inordinate amount of my time and energy working on getting that rule out. So I'm with you 100%.
Okay, thank you for your time. No more bad examples from Australia.
All right. Hey, I point out that was an individual operating outside of the regulatory structure in Australia. I want to make sure everybody understands that is not typical there.
Thank you, Mr. Williams. My name is Wes Oliphant. I'm a structural engineer, actually, out of Houston, Texas. I'm very pleased that the 4 categories that you just mentioned are things that we've been trying to get an exemption or some form of certification to operate. High voltage electrical transmission line inspections, as well as oil and gas refinery flare inspections. I would add that we also do inspections as well on high telecommunication towers, which have microwave and other things that make it very dangerous to climb. So when we went to FAA more than 18 months ago, we were not directed to this Section 333.
Did you come to my office?
No, sir. We did go to your office, yes, but I'm not sure you answered it. We were directed back out here to get a category exemption for operating, and then when we followed that path, it was as onerous as getting a Beechcraft aircraft certified, which we have a 4-pound octocopter from Germany that we'd like to use. Mm-hmm. So I guess my question is, again, I'm very pleased that that the office is finally coming around to it, because I understand the risk probably as much as anybody as a structural engineer, and the safety aspects of doing what we do. There's been numerous helicopter crashes doing what we do. There's been numerous people fall off towers doing what we do. So using something I could keep my 2 feet on the ground and do it makes it extremely viable. I guess my question, when is it going to be something that I could move forward with, in your estimation? And is it going to be limited to just those, or is it, again, some of these other safety things, that doing undersides of bridges, things like that we also expect to be able to do?
So the way the law reads is it's limited to essentially what we believe where it would be safe to use. So the way the process works is an operator, somebody like yourself, has to come in and ask for an exemption with a safety case that says, here's why I think I should be granted this exemption. So the companies that are coming in and talking to us are some of the big folks who can afford to pay people to do that. Once they successfully get that first one done, and it will be public information, it's published in the Federal Register, you can duplicate that and come back in and ask for essentially the same privilege that was granted to them. So I can't tell you a timeline because it's really dependent upon the industry coming to the FAA and us getting them through that exemption process.
In my instance, again, not trying to belabor it, but we operated 47 different states last year.
Mhm.
And that was one of the other obstacles that we ran across. They wanted us to very well define the operating space we were going to be in. Well, I mean, I operated in the US, so that was another obstacle that hopefully we can address when time comes.
Yep. Yeah, because the operating approval will be separate because the exemption will just be for the airworthiness piece. You'll still have to get an operational approval as well.
Hey Jim, how you doing? Thank you. My name is Brian. I'm from AeroCine. I'm from New York. We have a professional fly cinema grade cameras for motion picture film. Currently, we are flying in Dubai, Mexico, everywhere outside of the U.S. And being in New York, you can only imagine how I get requests to fly a drone down Fifth Avenue, and I don't do that. Okay.
Thank you.
So you're welcome. Well, and I don't want to do that too. I get a lot of requests to do like public things, flying over crowds, and that's like not my thing. I mean, I want to use it for motion picture closed set environments. We all know that there are constant stories of helicopter crashes on movie sets. I mean, the Twilight Zone is probably like the most famous incident. But being an example that you use, the film industry, I didn't know about 333. There are incidents where I've been on set where the helicopter and the real helicopter for acquiring the scene, every radar thing, every signal's going off, and the director's saying, go closer, go closer, go closer. So a drone would definitely rectify that. So I'm just kind of curious, I got a call from the Wachowski brothers. They did The Matrix, and they wanted to shoot something. What kind of timeline do I have to actually call you and be like, okay, I want to do this. This is why it's safe. This is where we're going to shoot. These are my certified pilots who've been doing this for 20 years. Like 10 days? Is it a month? Like, is it possible even?
Yes, it's definitely possible. I can't give you a date because we haven't done it yet. I mean, I don't know exactly how long it would take. The procedures would have to be in place for us to do that. But we approve police operations to go off in an hour or less. Right. We actually approve the Arlington County Sheriff to operate their aircraft within the Class B airspace around Dallas-Fort Worth Airport in a matter of a couple hours, and I think it was less than 2 hours because they had an active hostage situation. They needed to put it up, but we were able to coordinate with the air traffic control facility. We were able to coordinate with the police officers, and we were able to make it happen in short order. Now, obviously, a movie filming isn't as much of an emergency as a hostage situation, but
you'll be surprised.
But the bottom line is that I think that as we begin to develop, once that first one is approved and we got a company out there operating, we'll begin to develop the procedures by which we can authorize these things quickly.
And that is obviously on a case by case. I'm not going to have a blanket annual thing. That's like, oh, we're doing this in New Jersey on this road. I have permission from this authority, this authority. Now, that's my other situation, which is, let's say there is a ruling from the FAA. Okay, let's just say Spider-Man 8 wants to shoot in New York. Okay, I get a phone call from Spider-Man 8. Hey, we're going to pay you $1 bajillion to fly a drone, do this, do that. And I get permission from you guys that, all right, it's scouted. He has pilots that are certified at the highest level, people who actually fly real helicopters, motion picture industry, blah, 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 insured, everything. Does the mayor's office, in order to film in New York, you need a permit from the mayor's office. At what extent does your authority supersede, or does their authority supersede? Like, can I call the mayor's?
So the way the authorities work, if it's in the air, access to the airspace is the exclusive authority of the Federal Aviation Administration. Now, where you take off and land, they can get involved with that. So they can tell you, oh, you can't take off and land from here, and there's nothing really we could do about that. So
there's just going to be like a conversation that needs to happen between whoever owns the ground where I'm standing and the FAA.
Yep.
Okay. All right, cool. I appreciate it. Thank you.
Sure.
mission that was summoned by it. Yeah, yeah. UI does have like appropriate things. I'm doing a shoot there right now.
Cool. Hi, good afternoon. Rory Paul Voltaire, Robotics. I featured in your presentation, by the way, precision ag, without you knowing it. I have a question in two parts. One is November last year, FAA spokesman Les Daw publicly announced that agricultural users, farmers, could fly UAS under AMA guidelines. Take that data, apply it to their operations. Does this not constitute commercial use? One.
So you really don't want me to answer that question?
I really would, because I actually spoke to Les Daw in person.
So, all right. The way it works is, if I'm a modeler and I happen to be a farmer and I operate my model aircraft over my farm, as long as it's done safely, it's none of the business of the FAA what you're doing with the data you collect. We're not going to go get into that business. Our business is safety, not governing commerce. However, if you formally want an answer from the FAA lawyers about whether or not it is a business purpose, their answer is pretty simple. If you can deduct the cost of the aircraft from your taxes like you would a tractor or any other piece of farm gear, then yeah, it's part of your ongoing business, and it becomes it crosses the line from hobby to business.
Is this not an infringement of our Fifth Amendment rights to private property access?
I'm not a lawyer. I'm not getting into that.
I suggest that people actually look up US versus Cosby, 1946, where the Supreme Court allows private property owners access to airspace. US versus Cosby, 1946.
Access, not a problem. It's whether or not the aircraft is certificated and the pilot is certificated as required by the FAA authorizing legislation. That's really the issue. We're happy to provide access. Many farmers have aircraft that they operate out of their farms because they're just so big they need it to get around. Those aircraft have to be certified. Those pilots have to have certificates. That's the law. So we're not saying you can't fly your aircraft. We're just saying, hey, you got to follow the rules. That's all.
Thank you.
Hi, Brad Huber. I have a number of years of experience doing drone software development, and now I'm an investor and enthusiast in the space. And I'm a little bit of a betting man. I've got my fingers crossed that 2015 will open up the skies for broad commercial use. And I'm just wondering, from your perspective on the inside, would you say that it's likely the FAA will meet those timelines put out by Congress, and 2015 will have broad commercial use?
Well, I think if you go read the FAA's reauthorization carefully, what it says is that we have to create a comprehensive plan that describes what safe integration is going to look like in 2015. There's no words in there about full integration, full access, nothing like that. It says, and I've talked to the authorizers about what they meant. They said, look, we want you to put specific measurable milestones in place and get something done by 2015. And so we've done that. We've published our roadmap, we've published our comprehensive plan, and we've said the things that we're going to accomplish by 2015. The biggest being the small unmanned aircraft rule. If we can get that out, that's really the big step forward. But there are other things we're doing, like the Section 333 approvals, the restricted category certifications. There's other aircraft that are being certificated. So there's measurable progress all along the way.
Very good. And for yourself, if you were going to bet, when would you expect to see broad commercial use?
I learned a long time ago never to speculate. I won't do it.
Okay.
We're moving ahead as fast as we can while maintaining the safety of the national airspace.
Thank you.
Hi, Martin Veeramanikam. I'm at Euroclient Industries. Thank you for having this dialogue with the small business community. Appreciate it. Some time ago in Albuquerque, New Mexico, there was a UAV conference, and there was an Air Force general there who talked about all the regulations and policies and procedures they had for safely operating drones in the war zone and with their flights. So basically, in the war zone, as he explained it, you had missiles flying, you had bullets flying all over, and the Air Force had perfect flight of their planes without having problems with unmanned aircraft
Not so much.
engaging or running into. They did get shot at by the enemy, and even in the
No, they've actually had a mid-air, I believe it was between a Shadow unmanned aircraft and a C-130 over in one of their operating bases, I believe in Afghanistan. So their record isn't perfect.
Right.
Go ahead. It's good.
We're
It
talking
is
about
good.
the early
It's not
war,
perfect.
right in the middle, when they had artillery shells and everything going at there. And they had a very good results out of it. And this was in a place where they couldn't control missiles and bullets flying around from the enemy as well as themselves. And through all this, you had the Army also flying their unmanned drones without talking to the Air Force, and they had 1,000 feet.
Actually, they
let
have
me
procedures
finish.
that they
Let me
use
finish.
to-
So the point being is they operated safely. They had a good plan, and they had very good results. The numbers that they had was way beyond what the current has in a non-war zone with the amount of flights that planes that normally have accidents. So with those kinds of numbers, and they were willing to hand the whole plan over to you guys, why can't we build on something that is tried and true and already works? And we know we have to change.
I mean, I work very closely with the DoD. They've shared their standards for pilot training, they've shared their standards for certification, they've shared their operating standards, but they will tell you that they take more risks than they're willing to even take at their military bases in the continental United States. The data over there is not 100% applicable to how we operate in the United States.
Right, it's
there are
very
a lot
unpredictable.
Right, but I can assure you that we're working very closely with them. We've got 2 joint tests going on with the DoD assessing, applying their procedures in mixed-use airfields around the country where there are actual military unmanned aircraft operations going on at the same airport where there are civil air carrier aircraft operations going on. So we are doing exactly what you were saying already going on. It just doesn't get publicized widely because it's within the military and under the military's control.
Thank you for this time.
Hi, Jim. Gus from License Copter. Thank you for showing up as well. I've been safely flying remote control model aircraft for over 37 years, and I've also safely been flying full-scale aircraft as a commercial pilot for 20 years. In my 3,500 hours of flight time, I have only seen 1 remote control model aircraft. And that was at a field that was adjacent to, it was an AMA field adjacent to a flying field over near Scottsdale. Now, this morning, Doug Davis was talking about, well, we're concerned about unmanned aircraft getting close to full-scale airfields. I don't think hobbyists, many people who are not hobbyists don't understand that there are a tremendous amount of AMA fields adjacent to full-scale aircraft flying fields. Van Nuys in particular, there's an AMA field just to the south of it. I've been there, and I don't think most people are aware that large model aircraft, LMAs, are allowed that weigh up to 125 pounds and can be gas turbine powered and can fly up to 200 miles per hour. I've seen them, I have video of them flying. How is it that they will continue to fly unregulated, but somebody flying a 2-pound plastic aircraft cannot do that to take a photo?
I argue that they're not unregulated. They're required to follow the rules of the air just like anybody else, and you can ask AMA, it's written into their...
But they're not regulated by the FAA, they are self-regulated.
The airspace rules, and it's even in section 336, which gives the AMA their special, the model aircraft operators their special status. It says that in no way does this section limit the FAA from enforcing its safety regulations. Model aircraft have always been subject to the right-of-way rules. It's written into the AMA guidelines, and if you follow the AMA safety procedures, you're following the FAA rules. So it's a misnomer to say they're unregulated. We don't require them to be certified aircraft or pilots, but the rules of the air apply to them as well. So, and AMA fields coordinate with the local air traffic facilities. They have procedures. They talk to them, and it's dealt with on a local basis, and it's perfectly safe, and it has been, and we believe that it will continue to be. It's the people who operate outside of the AMA guidelines that I'm talking about. The people who are using first-person view to fly beyond visual line of sight without an observer, which is totally contrary to the AMA safety guidelines. We work very closely with AMA. We think they promote safe model aviation, and we have a memorandum of agreement to that effect. So, I don't have any issues whatsoever with model aviation. What I have issues with are people who don't follow the community-based guidelines.
Okay, I totally understand. One other quick comment, because I used to own and operate my own Part 135 air carrier operation. And one of the reasons why I had to give up that business is because there were so many guys who were flying. In fact, we had a name for them. It was called bootlegging. They would literally rent an aircraft from a flight school or a flying club and fly people from point A to B. I followed the rules. I got insurance. I worked with the San Diego FSDO. I was and those are onerous regulations, as you know. I went through all of them. So my prices had to be higher, and I was constantly undercut, and I'm afraid I'm seeing the exact same thing is going to happen here. If any regulations are put in place, there are guys who, well, they're already out there right now. There's probably thousands of commercial operations going on today, and it's only going to continue. But guys like me, as a certificate holder, I cannot put my certificate at risk. So I am grounded. I have complied with as I am told, as I've been taught to comply with regulations and policy. I may disagree with them, but I have been complying with them. Meanwhile, there are many, many operators with far less skill than I have. And I know the FAA's intention is to make the national airspace more safe, but it is my fear and concern that if any regulations are put in place, that the national airspace will become less safe. Any comment to that, or?
Well, all I can say is I'll do my best to make sure that doesn't happen. And if you know of people who are operating illegally, all you got to do is report them to your local FSDO, and they'll investigate it.
There are people flying bootleg charters in King Airs, Gulfstreams, Bonanzas, Barons, and I've talked to the FAA about it, and they said we don't have the manpower to stop everybody. We have to catch them in the act. And so
that's true. You do have to catch them in the act.
They have to catch them in the act. And so if they can't do that with manned aircraft, I just don't see how it's going to be possible with the literally hundreds of thousands of small model aircraft that are out there.
Well, fortunately for us, most of the people want to follow the rules. They want to be compliant with the laws, and they will voluntarily comply. Normally, it catches up to you eventually. If you're operating outside the rules, eventually it'll catch up to you. But the situation is what it is. I mean, it's like speeding. The police only catch a small fraction, but by virtue of them being out there, they keep people close to the speed limit. It's the same sort of theory that we have to deal with.
Okay, I hope you're right. Thank you, sir.
Me too. Patrick, are we?
Yeah,
your clock says I'm 4 minutes over.
I'll keep it brief.
We are over, and if you're done, we can be done. That's up to you. Or do you want to take
We'll take one more.
All right, this is the second time I've seen you here, so you're sort of like the Grateful Dead of the unmanned aerial industry, so I'm following your tour. But I'm a recreational...
I'll be in Orlando next week.
Okay, right. We'll get the crew together. I've been a recreational hobby pilot for a long time, as I think a lot of people in the industry are, and then some find ways to progress to commercial use. I do a lot of stuff with search and rescue team, and it's a natural progression to move on to some of that. Do you expect that the regulations will warrant needing to be a full-scale pilot to do these operations outside of hobby-based use?
Unfortunately, because the rule is actually in the process where it is, I can't talk about what's in it. Currently, well, one thing I can tell you is that our legislation, our authorizing legislation, actually requires in the law that aircraft have to be operated by certificated pilots. Right. That's in the law, and we can't waive it. We have to be consistent with that.
But that's a pretty significant barrier of entry when you, for your standard small business owner.
You're making the assumption that when we do the small rule, it'll be the same as a
Well, I'm
private
hoping
pilot's
it's
license.
changed, because I think most people would agree you don't need quite the same level, at least within certain parameters, to make safe operations. So hopefully,
Stay tuned to the Federal
Great.
Register, and you'll see when we put it out where we landed on that, and then you can comment on, let us know whether we went too far or too short.
I'll see you at your next show. Thank you.
All right, run for office. That's funny. All right. Oh, hey, here's my master list right here, right where I left it. Well, that was great, and I have to say that was kind of historic in my mind, because we got a open dialogue with the FAA without the static of the military and the police. We didn't really even have to go there. We got commercial for that, and Jim, my hat's off to you for going, that half-hour questions. And also to the audience, I know there's a lot of frustration, and I'd have been upset if somebody would have cut in on my action with the moaning and groaning. That's my bag, don't cut in on it. The other thing we got here is, besides the trip to Vegas, I found myself a nice iPhone out here. Is it yours? You got to prove it's yours. I want to know your mom's telephone number. No. So did anybody lose a iPhone? Or I got this? I don't know. Well, I got to prove who owns the phone. So if you lost your phone, we got to talk about that. And our next speaker is Harshil Goel, and he's going to talk about a new technology that he came up with and invented. And this guy, I ran into him actually last year at last year's Expo, and he says, hey, I have this technology, and it, increases lift and decreases drag, and yada yada. He's telling me all these stories, and I'm like, yeah, okay, sure. You got a unicorn to sell me, I'll take the unicorn. But since then, we've talked more. They've been doing some stuff in the wind tunnels and whatnot, and I think that this technology that he's talking about could revolutionize aviation. So would you please welcome Mr. Harshil Goel.
That's a tough act to follow, right? So hi, my name is Harshil. I'm the CEO of VIRES Aeronautics, and I'm going to kind of change the flavor of things today and get in some really hardcore aerodynamics and kind of explain the history of where we came from. So what's the state of affairs? Well, the state of affairs is that low-speed aerodynamics really hasn't evolved much since World War II. And now that seems kind of like a blanket statement, and you should be immediately asking why. The short answer is it's really hard. It's really, really hard, and most people think it's a really done field. The other thing is that scientific research has shifted. So going into kind of a brief history of aerodynamics just from the way beginning. So aerodynamics started, in the 1890s, right around the time of the Wright brothers. There are a lot of people out there trying all kinds of different things. Basically, Joe Blow's going out there, throwing gliders, getting on all kinds of weird planes, building their own wind tunnels, doing whatever the heck they could do to somehow fly like a bird. Then came the 1920s and 1950s, and all this stuff started to kind of get refined. All the guys at Germany, Oxford, Pranol, von Karman and company, they started to really rigorize what it means to fly, what is efficiency, how do planes actually fly, what does it mean to be an airfoil. NAC came about. Then the war happened, and scientific research changed in terms of aerodynamics. Aerodynamics is a field that's traditionally been governed by military. There's been a military need, and aerodynamics has followed suit to fill that military need. Until the 1950s, almost everything was pretty much propeller-driven aircraft. But right around World War II, jet engines came about. And people wanted to build aircraft that were faster, they flew in the transonic regime, they were bigger. And the low-speed propeller flight kind of died off, just from a basic scientific money grant process standpoint. Then came the age of civilian aircraft and the new approach. The new approach to aircraft after World War II basically really heavily relied on aerodynamics. And you can easily see this in all the stuff that Airbus does, Boeing does. They have all these very, very complicated wings, turbulators, flow control. and they need all this so they can transport large amounts of people from point A to point B. If a helicopter could do this, Boeing would make helicopters. There's a huge amount of research that has gone into making hybrid laminar flow control, and this kind of new age of aerodynamics on the wing is what has made commercial aircraft feasible. And now we're kind of in the modern day. High-speed flight is cool, it's awesome, but now we're in the age of the UAV, and low-speed flight is very important now. All that stuff, all that research that had happened in the 30s, 40s, and 50s is now starting to become really important now. And I think a shift is happening in aerodynamics as a whole. So this leads to our mission statement. It's our goal to fundamentally improve UAV performance through innovation in aerodynamics. Not through necessarily battery technology or controls or cameras or sensors. Fundamentally make that craft better. So how do we do this? So this is a 15 wing, if you care about that. You essentially have air going at about 4 to 5 meters per second, and we've lit it up with some lasers. And you can see the smoke. You can see this boundary layer effect, this bubble. This bubble is what causes stall in modern aircraft. This is that bubble being solved. And what does this mean in the grand scheme of things? This means a much more efficient aircraft. I'll kind of go into exactly what this means. But this is just kind of the quick overview. So you start with the craft. You have this magnificent bubble forming. The way we fix this bubble is by essentially rotating the entire surface of the wing. If you care about it, it's the no-slip condition. This fundamentally changes the way air flows out of the wing. It actually shifts this bubble on the bottom, and bubbles are high-pressure systems, and this essentially increases the lift. This lack of turbulence and this lack of bubbles on the top of the wing also magnificently increases the drag efficiency of the craft. It also fundamentally allows the craft to stall at a much higher angle of attack. So in summary, what does this mean in like a very high-level systems standpoint? We have increased payload, we have increased range, we have decreased fuel consumption, and we have much improved launch and recovery. We can launch the system at a very, very high angle of attack, and we can also perform an actual deep stalled landing. Not a landing where you just completely crash, but like an actual traditional deep stalled landing where you can plop onto the ground. So this is our solution. We're taking existing UAS and adding our core aerodynamic wing technology to make them fundamentally better. So what does this mean for the UAS provider? For precision agriculture, this means that someone can literally fly their airplane at a very, very high angle of attack. Now, I'm not talking somewhere between 10 to 15 degrees. I'm talking on the order of 25 degrees plus. You can fly extremely slow, plow along, and basically get really nice hyperspectral imaging. On top of that, we can have persistent flight. So everyone out there who's really interested in worldwide internet or repeated comm channels or consistently flying along a pipeline, very slow, monitoring what infrastructural issues there are, this is the technology that allows you to do it. UAVs can't currently do this not because they're not engineered to do it, but because there's literally a physics ceiling. You cannot fly at a very high angle of attack and decrease your speed. You need to fly at a certain speed to maintain lift and payload capacity. On top of that, because of the added payload benefits, and we're not talking like small percentages, we're talking about fundamentally changing the wing. We can have much more robust cameras. We can actually compete against something like a Cessna, which can carry a payload on the over 100 kilograms. And currently UAVs only have payloads on the order of 1 kilogram. We can actually expand the performance envelope and allow for much more robust mission profiles. So we've not just done this in the wind tunnel, we've actually flown this, we've built numerous flying prototypes. Kind of zooming in on what this random system is. Here you can actually see a modified hobby aircraft. This one has ailerons, so basically this is kind of like lawn space. You can cover as much of the wing as you possibly can, and when you move this changing surface, it completely changes the airflow at that region. We're currently conducting wind tunnel testing at the University of Washington, and this testing is basically going to completely solidify all the stuff that we've done in our dynamic testing so far, and is going to expand the regime all the way up to about 150 miles an hour. So we're going to see exactly what this does in every type of scenario and every type of wing configuration. So partnerships. We're currently looking for development partners, current UAS manufacturers, current people who are actually creating solutions for UAS, and you know, everyone in between, because our system essentially fundamentally changes the performance envelope, and we're looking to see what exact tweaks you would like to achieve your mission objectives. Thank you. No questions?
Do you have any feel for what the added weight?
A couple metrics that we have right now. For example, because we're talking about fundamental CL increase, we're thinking on the order of at least 40% or higher. I'm projecting that number is going to be even much higher, and we'll be confirming shortly with the wind tunnel tests. We're planning on publishing all those results publicly.
Okay, yeah, I was trying to get a feel for CL increase plus structural weighting, kind of CL versus that.
Okay, so our entire system currently weighs on the order of about 300 grams, and our system is powered, and it consumes on the order of about 8 watts.
Okay.
That being said, everything has been currently machined by my own bare hands, has not been weight or mass modified, so those numbers are definitively coming down.
You love small business, right?
Yeah.
Oh, there's a question here from this gentleman about flight time.
Yeah, increase in flight time. What's your projection?
So currently we're projecting a current decrease in about 20% in drag. That number is again set to go up. In terms of exactly what that increased flight time is, it's actually going to depend on a whole slew of variables. For example, to kind of give you an indication of the complexity involved, if we, let's say, quadruple the lift for some reason, it means that we could theoretically reduce the wingspan, hence dramatically decreasing the drag way more than 20%. I have to defer till we publish those internal results next month.
Just one more question, if you don't mind. Do you envision this on like if you have a high aspect ratio wing, 12, 15, something like that, do you envision this being full span or is this partial span?
So the interesting thing about this, as I mentioned earlier, is this will essentially increase the unit lift, will increase the lift per unit span wherever you put it. So you don't necessarily need to cover the entire span. In fact, it doesn't really even matter if this system is behind the prop wash. The system still functions.
Thank you.
All right. Thank you, sir.
I wasn't up there, but if you want to talk to Harshil, I would suggest you talk to him. I have to say that the people that aren't local to this area, there is a lot of out-of-the-box thinkers, kind of like you just saw. Some of these, they are kids that I meet during the course of the work that I do here, blow me away with how smart they are, what they're thinking about, how they look at problems. It's exciting times. So, without further ado, I'd like to bring on our next presenter. Knut out here?
Right here.
Oh, hey, there he is right over there. Please welcome Knut Mo.
Hi guys, nice to see you all. Spent last weeks in Africa in the jungles dealing with rhinos and lions coming after us on a few occasions. I wanted to share a little bit about that with you guys and just give you a little bit of an update on how this task is being solved. We tried to have a new approach on this, and I'm going to show you some approaches to this that combines different technologies into a much more efficient way of doing the whole rhino poaching countering work. So I'm just going to show you a short video from this last week down in South Africa.
kaleidoscopic mind. I never meant to hurt you. I never meant to lie. So this is goodbye. This is goodbye.
Yeah, this is a short introduction to actually handling things down there. It's a huge country, it's a huge continent. Trying to cover it all is kind of a challenge. Just the Kruger Park alone, where we've been dealing, is the size of Israel. So we figured out it's not enough to just have one helicopter go up there and try to cover the place. This is a preliminary field report from our weeks down there. Please feel to ask questions afterwards. I will try to answer them as good as I can. The first thing we have experienced is that UAVs are just 1/3 about flying something. The rest of the time, it's about logistics and data utilization. So it's time you act like that and start to understand that this is not about seeing something fly. This is about actually collecting data, using that to improve your business performance. We were working with a campaign down there called Save the Rhino. This is Nelson. He was unfortunately dropped roughly 8 months ago, so he's gone now, along with roughly 80% of the rhinos in that area. If nothing is done by the next 6 or 7 years, there will not be any rhinos left to future generations at all. Remote Solutions is a solution provider for anything dealing with remote sensing. We're a Swiss company. We deal with UAVs. We deal with any kind of ground sensor to detect what's going on out in the field. We are a provider of various solutions, both within the perimeter security and these things. I cannot talk so much about that, but I will talk gladly about the rhino poaching. We work within different areas, including air and both fixed wings and VTOLs. We work with ground vehicles and with maritime solutions. Now, to share with you how we deal with this is that we see the UAVs are information collectors. The different remote sensing apparatus is of no use unless you actually process it and use it for something meaningful. So in everything we do, in all solution approaches, we have a information processing part of that task. There is no use in processing it unless you also have some sort of reception on it. So you make sure that the information you receive is processed and sent to the people making the decisions in real time. So everything we do here is in real time with all the complexities that involve. The systems we use for the rhino poaching is complementing what's already in place. So this means that we're not there to remove all the other tasks out there. We are there to complement them and to make sure that we can use even tougher technologies that are always available to catch more poachers in their act of doing their action. Remote Solutions, we combined all the different technologies into one intelligence stream, which means that you have a lot of devices out there that combine everything from UAVs to subsurface cables that actually are able to pick up the footsteps of the people walking through the jungle, which is kind of cool. I'm going to show you how we're thinking about this. For instance, in the Kruger Park, we used a dedicated area that we wanted to cover, and we expanded that, so we created a perimeter around this area that we were watching closely. We used a combination of flying vehicles, of ground radars, shot detection, and various other devices. To do this, instead of blindly sending UAVs out to try and find, have you ever seen the African jungle? Have you ever been there? Raise your hand. There we go. It's kind of big, isn't it? And it's really, really difficult to see anything at all. So instead of sending UAVs blindly out to find something, devices to find out where points of interest or persons of interest would be trespassing in the park. And once we had that positioned, we would be able to send out a UAV to verify or even show force on the ground, and perhaps even also prevent the actual poachings themselves. To do this, we used some pretty good products. Well, flying is 33% of the work, but the systems we use they need to be good. So we used a system from Electronics, which enabled us to have extremely good proximity control of the ranges going at it out there. The systems would follow cars, would be on top of the cars to see what's around roughly 1 kilometer, using a combination of thermal and optical sensoring. Furthermore, we used a really good system from Seydoux, also here today. We will see just a short video clip here of how that actually works in the field. This was collected roughly 10 days ago at the Makalali Game Reserve. It shows the team setting up the system at dusk, sending it off into the African night. Takes roughly 5 minutes to set up. It's a parachute landing system. It's launched by a catapult like that. Now that gives us a system that allows us to fly up to 30 kilometers away from our base of operations. Now, that's a pretty good chunk of land. It gives us a good thermal view of what's going on. And this is a night operation, so we're doing it at night. And you see here we found 3 rhinos moseying about close to the road where they are going for some eating, basically. So as you see here, even though in the dense underbrush, you're able to easily spot and see your animals down there like that. Furthermore, you're able to even follow vehicles of interest, follow objects of interest on the ground to ascertain what their intentions are and to see how you want to intercept these various objects of interest. In addition, we put sensors on the ranges down there. We gave them a secure voice communication set, because the easiest way to avoid the ranges is for the poacher to pick up a radio scanner. You can hear everything's being said. So there are so many completely basic changes to make down there. But this system gave the rangers both the opportunity to collect evidence when they approached at the poaching scene. They would see everything going on, and they would collect the evidence. So we certainly had a video evidence of what's going on, which will make the digital process much more easy and much more informed for all people down there. These systems enable rangers to be around in the bush for a week at a time and record things that should be recorded, and also stream information back to headquarters in real time. Just push a button. You see the button right to the left here. Just push it, and the stream is received on the headquarters within seconds. So it's a pretty nifty solution as well. Looks like this. In addition, we also did gunshot detection, which is a reactive tool when you're dealing with poaching, because once the shot is taken, there's not much you can do for the animal itself, but you can be sure to try to catch the guys who did it. And by deploying a set of audio arrays, you're able to actually vectorize the audio information of shots being taken, and you can triangulate the position of that shot. That's pretty cool because it means that when you launch that fixed-wing system, it will go straight to that point of shooting, and you will be able to not only get an idea of what's going on, because you can put the drone in a on station above the site, but you can also go down to 50 meters, just merely above the treetops, and show yourself. Remember, this is at night. It's pitch black. There's nothing you can see there whatsoever. But you can also use strobes to mess up the night sights of the poachers down there, so they're not able to actually find their way back to where they're coming from, and make it easier for the rangers to apprehend them, which is a pretty cool thing as well. So you can not only use the drones for overview, but you can also use it as a show of force to see that you are being watched. That changes people's behavior. They will become more afraid, they will want to leave the area, and want to leave the area quickly. People that leave the area quickly make more mistakes. It's easier to catch them. We also use something called a high-definition ground radar, placed high above the surface. You can easily see movements in the park or in the state where you want to be able to go and check what's going on. This is an example. You see a road and you see cars moving on that road. The radar enables you to see all movements and to actually respond to them using UAVs to go out and check what's going on. Looks something like this. For future longer-term projects, we'll also be inserting various cables that gives you the footsteps surveillance that you want. People cross over it, and you will be able to actually hear that people are crossing over a line they shouldn't be crossing. To drive all this, we set up a LTE network with 30-kilometer range that gave us a 50 to 80 megabit connection all over the park. It gave us the possibility to stream live video and to have the positioning and the live information from all devices out in this area. And it gave us the possibility to do that securely. Most UAV downlinks today are not secure. They are done on radio frequencies, and that's a major problem, not only for us, but for also law enforcement that needs to have a certainty that the data links are completely tamper-proof and safe, secure. To finalize the setup, we also set up a resource center at the reserve headquarters that gave us total overview of what's going on, and it allowed us to run a system that would give us a complete common operational picture, so we know what's going on, we know what resources we have, and we know where we can allocate those resources quickly, which would look something like this. So we have a map, we are seeing a car, and we are seeing where in that map that car is actually operating, which gives the operators a much better sense of what's going on. It allowed us to see shots being taken. It gives us the location of those shots and makes sure that we can respond to those threats immediately using the UAVs, right away without any kind of hesitation. It even gave the rangers the possibility of just using their cell phones to collect the information and immediately have it show up in the maps. So, I'm just going to show you a quick clip here. This is what the system is capable of, showing a major strategic map of what's going on in real time. All your capacities are shown in here. All your resources are shown with what area they're covering. This is a UAV covering the ground. You see the video draped on the ground, so we see exactly what the drone is looking at. You see your forces, you see where you have coverage, you see where you don't have coverage. This is incidentally here in San Francisco, just for a show, just for this show here. And this is what you need, because once you get into all this big data, you're actually able to start making models and predictions and seeing when do poachers arrive at the site, What do they actually need to be in place? Do they do it on moonless nights, or do they do it with nights with full moon? Is the temperature an issue? If are they always coming in on the same road? Use big data to predict what's going to happen next. And when you collect all the data, you can actually start working with it. And that's one of the big challenges of working with UAVs, because you produce such a huge amount of data when you do this work. And this whole model is future-proof, because once any kind of new technology shows up around the next corner, which it probably will, we're able to plug that in and use it for the same purpose in the same model and collecting data to the same system. So that was just the background to show you how we actually do this. And the basic model for doing this kind of poaching countering is to detect. As you see here, we use all the detection devices. We have a resource center that processes and visualizes this, so we can actually make ourselves understand what's going on. We observe by using UAVs, by using tactical UAVs to find out what's going on, and we finally decide and act what to do and do so efficiently. So enough talk. These are, you have to excuse the layout here, but this was done on first one plane from Johannesburg to Oslo, then one plane from Oslo to here, so it's a little bit work in progress. It's quite fresh. But these are the raw feeds we received in the resource center. I will try to explain what we're looking at. So first here, we're looking at the strategic view of a fixed-wing system on patrol in Kruger Park. What we're seeing here is not the video feed, but is a map feed that we have the metadata of the position of the drone and where the drone is looking, so we know what you're looking at. I will show you why this is important. And we're able to to map out threats in that area and to make adjustments continuously to make sure that we have a fully understandable operating picture. All the data that you collect here will be in your data warehouse. You will, 2 years from now, you will be able to go back and see where did you fly on April 26th. We flew this pattern. And using that data is, as we talked about, highly valuable. You can even also see a quick view of what's going on from the different systems like this. So, for the Rhino monitoring, we had a strategic view that would look like this. You see the area, we have some possible sightings of rhinos. You see the position of the drone, and you see where the camera is pointing, so we know exactly what you're looking at. This is, when you're looking at a forest the size of Israel, it's hard to know what you're looking at specifically, so we need to have map support in order to make this work. Because what you get from a UAV, and this will probably get better down the line, but it will still be something like this, right? It's the middle of the night, it's pitch black, and you're getting a video feed that gives you extremely nice, sharp pictures, but you don't know what you're looking at. But when you put this side by side, it gives a much better understanding of what you're doing, because you will get something like this. And suddenly it starts to make sense, right? Because once, we'll see here, just bear with me for a few seconds. Checking your watch here. Yeah, you're going to be good. Just a little longer. Hours of watching this kind of video is fun, right? There you see the rhino down to your left. Now you have a whole pack of rhinos in the center of the image, and you can confirm that you have seen them. The drone is repositioning, and you have the camera back on the rhinos right there. You see the 3 white dots in the middle there? That's the pitch black African night finding rhinos in the dark. Pretty cool. So in the end, the resource center will get an image like this, where you have the strategic view, you have the view from the rangers on the camera on their jackets, you have the helicopters out there, and you even have the fixed wings providing an image in the control room that looks something like this, but it looks better, of course, when we have the good screens over there. But this is the kind of situational awareness you must have in order to actually make the anti-rhino activities work out. That's how it looks. This is the method that we used, and it's been really working well. And it's what I was prepared to show you today.
We're running a little big off. That was great. I think I got a whole new catchphrase. Like finding rhinos in the dark. That could be kind of dangerous. Okay, well, now we're up on our... Whoop, right. It looks like there was more of the presentation. We could have went. But,
You're going the wrong way.
Am I going the wrong way? We already see all this? Sorry. Went the wrong way. All right, well, we're going to take a break. We're going to take a 20-minute break, or actually like a 15-minute break, and then we're going to get a demonstration. So go help yourself. There's still some sandwiches, and there's soft drinks and water. A couple, if you're still hungry.
They said that they're Yeah, so not everywhere. You get these people say spectral, and you have
not just two.
I'll introduce you. All right, can we get back to our seats because we're going to get a demonstration from drone deploy. So let's start heading back to our seats. All right, we got to keep the show on the road, so I'm going to invite Drone Deploy to come up here, and they're going to give us a demonstration of one of their new products. Right? It's a new product, right?
Yeah.
Everybody's not sitting down, but we got to keep rolling, so I will turn it over.
Cool. Speaking to the mic. Yep, good.
Test, test, test. All right. Should I sing?
Thanks, Patrick. Hi, everyone. My name is Mike. This is Jono. We're from a company called Drone Deploy, and we want to fly some drones from stage. What we're doing is we actually trying to build better software for drones. We're trying to make them easier to operate, safer to use, and much easier to get the data off them. We're doing this in two key ways. First thing is to use the cloud. Our drones are part of the Internet of Things. It's possible to not just to control them, but to control the sensors on them, to get the data off them and process it in real time, so by the time you land, you can actually have done something with your data. The second thing that we've done, which is pretty cool, is connected them over cellular. So our drones are all controlled wherever they are. They have unlimited range, and they can actually pass any type of data back to the users. Doesn't matter where they are. We can actually fly drones and assist our friends who are flying in the United Kingdom or anywhere in the world to fly their drones. We can actually control drones from unlimited range in any place and get the data off it. I'm going to ask Jono to give you a quick demo of our software.
Right, I might stick to this one because I can use my fingers. Yeah, so as Mike was saying, we're building this very, very powerful cloud-based infrastructure. That means controlling a drone from a number of clicks from anywhere in the world. You sign into our platform, and it's all about the workflow. What is the result? What are you trying to actually get done? So let's do a quick example of doing an orthographic map. It's as easy as saying, all right, I want to fly on one of my n number of drones that I have connected to the platform already. What kind of camera am I using? And you click Create a Flight Plan if you want to search to a different location. Because these things are connected, because they're on the cloud, we have amazing bits of data coming in from disparate sources. So we're looking at something like, this is the current wind data right now as we speak for Golden Gate Park. We've adjusted the flight plan accordingly so it's flying into and with the wind in order to minimize roll on the camera. We've taken into account elevation data so that you aren't flying into mountains or buildings. And all of these are being pulled from different resources. So starting the mission is as easy as clicking fly. Oh, seems like someone's using demo 1. Let me try it on demo 5. So you just click fly, and then that connects directly to the drone. It will upload that mission plan. It will start doing a bunch of safety checks, or at least it does on Chrome. And then essentially what's happening is the entire mission is being sent to the drone and programmed onto the drone. You can add a bunch of other ones as well. So here is another one that I was setting up earlier, and it's busy flying around taking a map over there. The very exciting thing is that we have the control over the cameras as well. So we can start cameras. This is all simulated data. We aren't controlling real planes right now. But we can control the cameras and get data back from the sensors from anywhere in the world. So we can actually see what's happening, where these things are, and how they're flying. That data is being pushed back into the cloud. So as Mike was saying, in the middle of your flight, we're getting that data and we're stitching that data and we're creating a result for you. So here is an actual mission that we did in that area, and you can see the existing map versus our map. And this is displayed in such a way that you don't have to try and send somebody a several hundred meg or several gigabytes GeoTIFF file. It's a link, and they go to it and they can see it. And there it is there. A friend of ours added a marker saying, look, I found some golf balls. It's pretty exciting. But essentially the great power of this and what we're building with this is the ability to manage and control many drones from the internet. And so we're building this internet of drones that lets you do incredibly powerful things.
Yeah. So what we're trying to do is we're trying to empower this industry with better software. We want people already trying to do all these things. We're getting great farming data, surveying data. We want to make it simpler and faster for people to do it. We're looking for partners to try and help them do these things, to get it done faster and simpler, and to share the tool of drones. What we're doing to start is we're actually looking for 50 partners that we're going to work with to provide them awesome customer support as we enable this new type of drone control. If you guys go to our website, you can actually join our Explorer program. What we're going to be doing is we're selling our cellular telemetry radios, and that will give you access to our platform and enable you to do amazing things with drones over the internet. Thanks. If you have any questions, just come on to us afterwards.
I missed that whole deal. What a loser. I know. Wait a minute here. Technical difficulty. Which was one of the reasons. This thing is working. Let's just do that. That's it. Yeah, but how do you do it? All right. I think you have 20 minutes. Yeah, but now it's not working. So somebody messed it up, so you gotta have to little arrows. All right, our next presenter is, he held a meeting not too long ago out here at NASA Ames, and this is NASA's effort to help with the airspace integration for unmanned aircraft systems. And I'm not even going to massacre your last name, Parimal. Would you please welcome Parimal from NASA? You're gonna have
All right, good afternoon. My name is Parimal Kopardekar, but my user-friendly name is PK, so you can call me PK. And I'm also happy that you all asked difficult questions to Jim, so I don't have to answer any one of those. I'm going to talk about how we think we can enable the civilian low-altitude airspace and particularly UAS operations by a construct that we are referring to as UAS traffic management, or UTM, which is analog to ATM, air traffic management. Okay, here we go. So most of you know the airspace classification, but just a quick refresher, we are focused on the Class G airspace, the low altitude, 2,000 feet and below. Most of these operations that we are referring here, low altitude operations, are likely to occur in 400 and 500 feet, but they could go up to 2,000 feet as we know right now. They could change, but that's the focus of our work right now. So quick outline, I'll talk about the motivation, why we are doing this work, what's the sense of urgency, which all you know, so I don't really need to talk much about that. What are the key design functionality, architecture options and alternatives, some demonstration options and business models and partnership opportunities. Sounds like every one of them have a partnership as a slide, so I felt I should have one too. And our next steps. You all know that there are lots of applications, so I don't need to talk about those, but what really the key here is many of these operations will occur at the low altitude, which is where the businesses are going to thrive in our mind. And these are not going to be only UAS, there will be personal air vehicles as well. And we really need some kind of infrastructure to safely accommodate these operations. That's our goal. There's of course global interest that's seen here. Fundamentally, what we are after is this lesson from history. If you look at 1956, the mid-air collision over Grand Canyon is how the air traffic management started. So we began to think about this and said we really need to have a system in place so we really don't repeat the history. That's kind of the main motivation why we started this research and development. This is our notional scenario. I don't think I need to spend too much time here, but we really are talking about two different systems. There is a persistent system and a portable system. Portable system is going to go from one landscape to another landscape. You can imagine something in the back of the truck with maybe low altitude radar, maybe some internet-based app that you just saw. But that will go from landscape to landscape. And really, what we are attempting to do here is accommodate heterogeneous operations and heterogeneous vehicles and heterogeneous businesses in the same airspace. So you can see search and rescue and surveillance of key assets and picture taking and UAV following car and cargo delivery and all kinds of things. So there is obviously sense of urgency. You know, the co-op process is very limiting, as you all are frustrated with this. As we know, we need to have a system of rules and regulations urgently. So we have really two goals. One is the near-term goal is to try to enable these operations within 5 years, as soon as possible, but within 5 years. And second long-term goal is to enable the highest safety for these operations, which are going to increase in the massive scope. So we need to accommodate these operations in 10 to 15 years. We see a tremendous, basically, scale of operations. So let's say if we are an operator, if you're a drone operator, UAV operator, what would you like to know? You know, fundamentally, what you want to know from the perspective of entering into that airspace is that airspace open or closed? So you can see that our talk here is changing the context from vehicle to a single mission to entire airspace. So that's the idea here. We want to know whether the airspace is open or closed right now and in the near future, whether which airspace can I operate in and which airspace should I avoid? Will there be anybody else in that airspace? At the same time, I will be. What should I do if I need to change the trajectory? You saw the drone deploy, so there's a good example there. How to manage a contingency, and we'll talk about the different contingencies. And who should operate this airspace? So this is another interesting question. And how should we operate that airspace? So let's look at the design functionality that we think we ought to have. First one is airspace management, and this term geofencing. You may have heard this term before. Idea is to fence up things where we need to keep them clean. So there's an airspace that is fenced up, and you need to operate inside that airspace. Rest of the airspace you avoid. There's going to be interesting weather and wind challenges from our own research and the trajectories and integration of weather and wind. We found out that some of these vehicles will fly backwards if you have wind of 15, 20 knots. So we really need to understand how these vehicles will operate in the context of winds. Which winds are safer? And when do you actually say that these airspace is open, given the context of wind? New York City, if you really wanted to operate in New York City, which I'm not saying we should, but the eddy currents that exist between the alleyways are interesting challenges. So then predict and manage congestion is another thing. Eventually, we are going to have large-scale operations. So how do we predict congestion, demand and capacity imbalance, which is what we typically do for classical air traffic control. Then terrain and man-made objects, database and avoidance, we all know where to find that, and we know how to integrate with that. And we want to maintain a safe separation and then allow only authenticated operations, that point that was made before. Some question, why do I need to have a system? Why do I need a system to begin with? And the analogy there is, you have a car, whether it's self-driving or person driving, human driving car, doesn't really eliminate the need for roads or traffic lights or rules. So that's the same thing. We need to have some kind of a system that will enable us these operations at low altitude. So examples, and I won't talk about all of them, but authentication, some kind of authentication, rules of the road for airspace, altitude for direction perhaps in the beginning stages, areas we want to avoid, CNS, there are lots of options for communication, navigation, surveillance, low altitude radar, there's a cell phone coverage, there's a whole bunch of other options are available. Separation management functions, there is lots of effort that's going on. So we are not focused, this particular effort is not focused on sense and avoid, but more on the airspace aspects and the weather integration. Contingency management, this is an important aspect. A lot of folks argue, and we have good discussions about that. We know how much contingency management we should build into this system. So we really want to not only consider the lost link scenario and the rogue operations and crossing over the geofences and what to do when those things happen, but we also want to think about what could we do if there's a potential 911 kind of a scenario, and we have to have this direction that says everybody should land to figure out who is still a rogue operator in that airspace. So we need to have ability to get to that point of some way. Congestion prediction, figuring out how do we actually predict congestion in certain airspace, what to do with it, by scheduling or reservations of the airspace, and overall design. Obviously, we don't want to make the design of the UTM so cumbersome that it will be expensive, prohibitively expensive to operate. And then we need to continuously collect data about performance monitoring with respect to the geofencing and the trajectory prediction and the trajectory conformance. And ultimately, we really have to worry about the last 50 feet operation and the first 50 feet operation. How do we descend and ascend in the presence of moving objects, grandma mowing the lawn and all kinds of things, kids playing soccer. So there's a body of work that's going on in that direction as well. So I won't go into too much detail here, but basically we need some of these key characteristics in terms of ability to support diverse mission business trajectories. We need to be able to provide reliable communication navigation of some kind, must be able to accommodate all kinds of vehicles who are autonomous, who are not autonomous, and must be able to provide some kind of congestion management, route planning capabilities. So this is a sort of overall design option, one of the options anyway. Ultimately, we want fully autonomous city, IEEE term, if you will, that goes into that, which self-configuration, self-optimization, self-protection, self-healing of the system that is going to take care of this. So sort of an autonomous system, if you will, which will have all these features that I mentioned before, which is connected to the wind, real-time wind prediction, the airspace constraints, any community-based concerns about noise, sensitive areas, privacy, so you can do the geofencing and dynamically adjust the geofencing and such. Then if you are a operator, so how do you access the UTM? Ultimately, we want this to be a cloud-based service where users access through, all users access through internet. They will be able to generate and file a nominal trajectory, adjust the trajectory in case of congestion or some preoccupation of the airspace, verify for all these conflicts and things that you need to avoid, verify for usable airspace, verify for winds and any bad weather situations, monitor trajectory progress and adjust the trajectory as necessary. So these are the functions that will be afforded inside that. If you are a UTM manager, what would you do? So if you're a manager of this system, so you will set up the design of the airspace, you'll set up the functions so that the fleet operators as well as the singular vehicle operators can also use that airspace. Then it will be overall schedule-driven system to make sure that there is strategic deconflictions, at least in the beginning stages, and eventually it will be a lot more dynamic and agile, just like the air traffic management system we have. And largely, we want this to be managed by exception, so not a person, one single person watching every UAV in the sky. It's automatically, autonomously managed. So we conducted a workshop to get idea related to this concept, get feedback from folks. We had 145 non-NASA folks, a whole bunch of partners that have emerged as part of this workshop. You can see all the happy faces that attended the workshop there. And the main findings about the workshop were there is overwhelmingly positive response about this construct of UTM, with strong support for NASA's ability to lead this, and many partners are ready to engage, and there is going to be an urgency to put this system in place. So how are we going to do forward from where we are? So the way we are going to architect this approach is to construct a number of builds, which will evolve over time. And the first build is, the goal is to mostly show the information. So it's a static display of the geofence, or airspace definition, altitude for right altitude for direction, and basic scheduling and such. And then next one will be the dynamic adjustment. So that will be the build 2. Then build 3 will have contingency management, separation assessment, and the build 4 will be the large scale contingencies. Now the question is, how do you want to participate? How will you want to participate in this? So we are going to set up ways where we will be doing the test of the builds, and we will be looking for folks to bring their missions and vehicles, so that we will evolve the UTM builds, collect the data, and then demonstrate that the system can accommodate everybody in the same airspace at the same time. That's kind of the goal. So the goal is to enable these operations. There's pretty good support of the UTM construct. There is already a parallel in the form of air traffic management. Many partners are ready. We will be more towards autonomy, and there's going to be a partnership strategy that's forthcoming related to this. I'm open to any questions.
Oh, hey, yeah, what happened?
So I can do without the microphone, probably.
No, we won't.
Yeah.
Hold on a moment. Everybody wants to hear this great question.
No pressure.
No, I've actually, I'm thinking, aren't you overcomplicating things? How, for example, do you want to do communication between the vehicles with this system? Or is it just defining airspaces and without any communication?
So the V2V communication should have to be based on needs. What are we doing V2V communication for? Are we passing the information about the weather in the front, or are we simply doing V2V communication for collision avoidance? So that's the construct that we have to define. Some operators will have V2V, others may not. So we want to accommodate both kinds of operators.
Okay, because in the car industry, this already has been done. You have a system called, well, you have ITS, in car-to-car communication. The protocol has been defined. Also the hardware for that is ready. You have the 802.11p standard for the communication between vehicles. I think this is really overcomplicating it, and the things that they're putting in the cars, can easily be used in these systems like this. The cost will be low because the number of cars sold and that will have this technology on board will make it also very cost efficient. And I think if you're going to do it all over again, it's a waste of time. If there's already a system in place that can be adapted to these systems, because the systems we're talking about, 99%, are the vehicles that are operating at low height, probably have the same speeds as cars maximum, and are operating in an area where they have to communicate with other devices and other, for example, cars or buildings. That's exactly where this protocol, this ITS, this car-to-car communication, car-to-X communication, has been designed for.
Yeah, so I'm not sure I understand your point that we are overcomplicating, because there is more than just a communication. As I said, we want to be as minimalistic as possible. Maybe it's not required at all, and I don't think I said that we need to have car-to-car or vehicle-to-vehicle communication. Fundamentally, this is about airspace management.
Yeah, but that's
so ability to talk to the vehicles back and forth and monitor them is what's important, and maintain them in the airspace that we designate them to operate under.
But are they operating in airspace? Yes, well, due to law, and we have of course the FAA talk about it. But are they operating? Are they more operating in the airspace, or are they more operating in, for example, the space that we're living close to the ground? In the future, plumbers will, for example, use the systems to check roofs, or everybody will have maybe a small pocket drone, and if you want to implement things in these, you have to regard them more like the things that we see around us than as airplanes.
So this is where it comes to whether it's going to be a congested airspace or not. If you're operating in an airspace that is not congested, it's on top of your roof. There's not going to be probably other folks running around there. So that is not an issue. But if you're operating in an airspace that's going to be congested, then yes. So if you have a zip code that a bunch of deliveries are coming, it's possible that there is going to be trajectories that are going to be crisscrossing. So who is going to be responsible for making sure that these heterogeneous trajectories are kept separated? That's kind of and the airspace separated, right? So it's not just one vendor or one person who is.
No, but that's not what I'm saying. I'm saying cars that can.
We're going to have to cut it though. I don't want to, but we have to stay on schedule.
Well, we can talk more. I'd love to talk to you and make sure that we address the question. But thank you again, Patrick.
Thank you, Sam.
Okay, moving right along. We're trying to stay on schedule here. This is another guy that's been doing some work with unmanned aircraft in agriculture for quite some time. I tried to get him at last year's Expo. I couldn't get him out here. He was doing some stuff, but he was kind enough to come out here. Please welcome Rory Paul.
Well, Patrick, thank you very much for having me. I apologize that I didn't make it last year. Some of you might have noticed that I have a slightly strange accent. I'm originally from South Africa, but I find that I'm not alone. There were a couple other people from South Africa. South Africans have got some really strange personality traits. We tend to be a little bit pessimistic on one hand, but we tend to be optimistic that we can fix anything with baling wire. Okay, so this goes with autopilots and UAVs. So I've been working in the ag sector with UAVs since about 2006 formally. The first time I saw a UAV used in ag was back in South Africa in 2003 with a large multinational agricultural company. We're using a gas helicopter with a 35mm film camera. So for some of you that are new to this field, you're thinking that we're just starting off. People have been putting cameras on radio controlled planes for a long time. So we're going to talk about agricultural usage. And if I can get that trick. There we go. Right, so 2006 until 2013, my telephone did not ring once. Okay? What happened in 2013 that changed the industry? This very well-known graph that AUVSI put out that said in the next 10 years, drones or UAVs for agriculture is going to be a $180 million business. All right? The phone went crazy. And people are enamored with the technology for ag. We want to get drones for agriculture. All right, but there are a couple of critical things. People are not thinking about this technology critically enough in the agricultural space. They think they can go out and start a UAV company or a UAV service company, and I would urge them to think about these things, these questions that I'm going to ask before they go out and do that. Patrick, this is not working.
Yeah, I know.
Oh, there we go. Okay. All right. This slide is a little bit hard to see, but what it represents is a section, 640 acres, corn, soybeans, etc., in the Midwest. There are about 160 million acres of corn and soybeans grown in the Corn Belt. All of this is potential, okay, data that needs to be captured in some way. So over here we can see the orange line represents the 640 acres, and the quarter section, 160 acres, is represented by the blue line. And I want you to think about this as we go through the slides. I don't know if you can see that little red dot in the middle. That little red dot is that 640 acres in a number of counties in the Midwest. And here we have the three I's: Iowa, Illinois, Indiana. the largest corn and soybean producers in the world. All right, and sorry, 84 million acres of corn, 74 million acres of soybeans. This is, our fields are ripe for using some kind of technology to image them during the season. Visual imagery, near-infrared imagery. And how are we going to do this? Well, the logical step is to remove the pilot and remove the aircraft and use UAVs. Now the question is, what type of UAVs? Small UAS, large UAS, what is going to be commercially viable, what is going to be practical? Farmers are very practical people. Don't stand in front of an audience of farmers with a John Deere hat on and expect them to believe that you work in ag, okay? So, some typical ag UAVs that are out there. We're not talking hundreds of these systems. The FAA would like to think that they're hundreds. We're probably talking about thousands of these systems being employed by farmers right now, because they don't believe that they have to report to the FAA. Okay? They're out there flying right now. So they're typical ag UAVs. DJI Phantom, 3D Robotics, Precision Hawk, and the EB from Sensi Fly, and a number of others that are out there. So what can you do with these legally today? If everybody can see this slide. Let's talk about FAA regulations and safety. How much ground area can I cover with a small UAS and pretend to comply with the FAA? That means keeping my UAV within visual line of sight. So here we can see the smallest rotary wing systems. You can't push a rotary wing system out more than a quarter of a mile and actually see it. It starts to disappear already. Then we go up a little bit. Okay, a small fixed wing, another quarter of a mile. So I can only get off, probably capture imagery-wise 160 acres per flight and keep that machine in visual line of sight. Slightly bigger UAV, if I'm standing in the middle of the 640 acres, we can pretend to see it. Okay, pretend. If we've got a spotter out there with a two-way radio, maybe we can actually keep the thing under observation. So right now, if you want to fly and stay within visual line of sight, the maximum you can do with a rather large UAS system is 640 acres per flight. Now, if your UAV doesn't come with a near-infrared camera and a visual camera, that means that you're flying twice. Okay? So how much service can I provide per day? How many flights can I go out and do? Now, this is something that the industry is not talking about. Other than producing pretty pictures that the farmer is going to put on a fridge, okay, this requires ground control. We need to put ground survey points out to actually build accurate maps. Now, remember, farmers have been using RTK GPS for years. This gives them inch accuracy. All right, now if we don't have this data, you could have floating errors, I'm going to talk about this later, of up to 60 feet. That's no good to a farmer. So you need to put, right now, you need to put in ground control until this is technical problems have been solved. So you're running around in the field and you have to have a guy up there on a quad runner, okay, and find some way to get your ground control into the middle of 1,000 acres of corn. We'll see a picture of 1,000 acres. So the next thing is efficiencies of scale. That 160 million acres out in the Midwest, I'm not even talking about California's high-value crops. How are we going to capture this data? What's going to be more efficient? Flocks of small UAS being operated in their thousands, or very large UAV systems? Which is more efficient? Which is cheaper? Okay, because right now, you can probably buy a second-hand Cessna for $60,000, camera system for another $30,000, and you can go to work providing imagery. But then we look a few years down the line, and what is more efficient? Solving the problems that we have today with satellite technology and capturing this information using satellite. So what I'm telling you is that the window in agriculture for data collection, we've got a window. All right? Maybe it's 10 years, maybe it's 15 years, but eventually the most economical way to actually capture this data is going to be satellite. Some of you might not like that, but it's probably what's going to happen. A farmer will stand in a field with his cell phone and order that imagery, and it'll be downloaded to his cell phone. That's the vision from a satellite, not from a UAV. Right, there's a lot of misconceptions out there. Some of you, this might be apparent, but others not. The difference between resolution and ground accuracy. A lot of manufacturers are touting resolution, and they bandy numbers about like 2.8 centimeter resolution, sub-inch resolution. That's the pixel size on the ground. Okay, now you have to ask yourself, where is that pixel in time and space? Okay, so over here, we've got 2.8 centimeter resolution, and I don't know if it's clear on this slide. You see the little yellow stripe on the ground? That is a 1 centimeter ruler. Now what this means is that theoretically, we can identify an individual corn plant in a field. Now the farmer needs actionable data. He needs to know where that corn plant is. So the next problem. Accuracy. Lots of flight planning tools out there using Google Earth, okay, as a base layer. What's the problem with Google Earth? It's 15 to 20 feet out at any one time. And if you don't have differential GPS, okay, on your UAV, you've got no way to correct for this without putting in ground control points. So you're starting off with an error of 15 to 20 feet to begin with. Then you go out there and you actually gather this data. Then what do you have to do? You have to process all these images, hundreds, if not thousands of images. And we have to correct for things like lens distortion, topographical distortions, camera attitude, and then we have to georeference it. And that's all reliant on ground control. Okay, at a minimum, we have to have 5 points. 4 corners, 1 in the middle. All right. Now, the algorithms are better as they get closer towards the ground control points. But as you move away from ground control points, this creeping error increases. Now remember, farmers are used to having this sub-inch or sub-foot accuracy. All right, and a sprayer's boom is only 15 feet across. And he might have multiple hybrids of corn or soybeans in rows. He has to tell the difference between one row and another. And if we can't deliver that, we haven't done anything. And nobody yet has told me how you get ground control into that 1,000 acres in the middle of the season. So, Patrick, I've left your audience with some things to think about, okay, if they're getting into the UAV business. Any questions?
Now's your chance to ask somebody who's been doing it.
Okay. Yes, sir.
Do you use double band GPS in the drones?
If you're talking about differential GPS or RTK GPS, we have the capability to do that? No, it raises the price of the UAV unit considerably. To my knowledge, there's only one company right now that is offering a low-cost, okay, RTK GPS solution, and it's literally been released in the last couple of weeks. Yeah. Yes, sir.
Hi, Bo from Aurora. I had a question for you about some of the methods that are using it. It's a little technical, but I don't know if you looked into some of these things or discussed it. A lot of what is out there right now is using GPS, kind of an absolute forum. But what I've seen coming up recently is a lot of localized ability to gain situational awareness using things like optical flow, in which case you're essentially mapping out the area in relative terms where you set a single point and then it's able to calculate distances and ranges over that whole area. They do that a lot with like the LiDAR stuff and so forth to get a map that continuously meshes as it grows. Have you seen anything like that?
Right. There are methods like this, but at some point in time you need an absolute position to correct everything. And if the farmer doesn't have that absolute position, you've got a problem. And so, for example, with RTK GPS, there are various networks around America that are providing these RTK corrections. If you don't have access to one of those networks, you're looking at a situation where you have to put down an RTK base station and you'll have to let it cook in the field for 24 hours to generate a solution. So your really simple, convenient UAV flight now becomes a process of camping out while you wait for the solution to be generated, and then go and fly the next day. So.
Thank you, Rory. I'm Paul from Mapbox. Really enjoyed your presentation. I'm wondering if you can speak a little bit on the distribution side. So once you've gone out and flown these missions for farmers, how are you delivering the imagery? What's the best way to connect with them? And
hard copy.
Hard copy.
Hard copy.
Physical media.
Yep. Again, some farmers, it depends on the farmer. There are growers out there that are using pre-existing services to manage their GIS requirements. And this is another thing. I've been speaking to a lot of people that they're getting into the agricultural data analysis business. What they fail to realize is that people have been in the agricultural data analysis business for 30 years, and they're 90 million acres ahead of you. So rather team up with them. But at the lowest level, farmers walk around with a binder, okay, with near-infrared imagery from last year, and they try and make a decision about this year. Sometimes that image is on a server in the cloud somewhere. Okay.
We're going to have Rory on the podcast so he can go into depth on that, because that's pretty interesting. Okay, we're going to move right along because we've got more stuff going. And our next speaker is Colin Snow, and some of you may have seen the story that we ran on sUAS News where we're asking people to respond to a poll. And Colin collected that data, and he's going to give us an overview of what that returned. And it's pretty interesting. Confirmed some of the stuff that I thought, and then also gave me some new food for thought. So, welcome, Colin Snow.
Okay, great. Okay, 10 minutes, that's it. For those of you who took the survey, thank you very much. We did a study on the impact of the rules on small UAS businesses. So this was a micro economic study looking at how businesses operate or want to operate, how many employees do they want to hire, what kind of revenue are they going to generate, what kind of services do they want to offer. We had a really good subscription to the service. Thank you to sUAS News. We got 297 qualified respondents. That's very good for a survey. 90% were from the US. 59% of them were involved in the drone business in some manner, either as an employee or as a principal in the company, and that's important too, right? So we're not just getting a bunch of droners who are out there wannabes. Yep. That's on the arrow now, and there we go. All right. Here's what I want to point out. This is a graphic to kind of illustrate to you the path that we're on. Under current policies, and I'm going to talk about this in the presentation and show you the data that backs it up. Current policies versus if we go towards favorable regulations or we go towards unfavorable regulations. Everybody knows where we are now. It's market uncertainty. I don't need to tell you that. But the news here is what happens if favorable regulations get put in place. We'll identify what those are and what the economic impact is. Or what would happen under unfavorable regulations. And basically, look, under favorable rates, no, this isn't rocket science. Under favorable regulations, there's market development. But under unfavorable regulations, there's market disintegration. Essentially, the market, it will get killed, and I have the data that shows that. And there we go. All right, real quickly, there were 6 key insights in the study that came forward. I'm not going to go through all of them. The slide deck will be available for you. I'll read them to you. Basically, the understanding of current FAA regulations, really widely varied. No surprise to anybody, just as Rory said, companies and people operate anyway. A lot. Aerial photography and cinema are dominating service offerings. That's current and in the future. It's not ag, it's aerial photography and cinema. Movies, TV, that's where the big money is. Fewer operators employ commercial liability insurance. We heard this earlier, right? You got to do it. Favorable rules will create economic growth, and unfavorable rules will kill the market. So let's look at some data. And forward. There we go. All right, undercurrent policies. Here's what's happening today. Today, undercurrent policies, 47% of the companies that we surveyed, they're operating anyway. And again, this survey was about Class G airspace. It was about operating with a small UAS under 55 pounds, right? And we said operate means you're flying. So 47% again, and most have been doing it for more than 2 years. Does this surprise anybody? Okay, all right. 71% of the surveyors, respondents said current rules are unclear, and half said they're very unclear. 30% said FAA doesn't even regulate the space, right? My space, you know, regulator. Well, and the reason we got that kind of response is, remember, this is post the Perker decision, right? So this survey came out right after that decision where, you know, the administrative law judge said, there's no rule. So I'm not surprised by that answer. Let's see, under favorable rules, what happens? Growth, right? Cumulative average growth rate, 49% across all revenue bands. No matter how much they made money right now, some of the bigger bands, you know, the largest growth area was for businesses who make under $1 million, 49% growth. 65% of those who are sitting on the sidelines would start their business immediately. Immediately, they start their business. 42% would hire 2 or more employees, right? So almost all the businesses that are on the sidelines say that they'd operate immediately and then begin hiring as soon as the regulations come out. What's a favorable rule? Well, a favorable rule, the way we did this, we gave people 12 options and we said, here's all the list of possible rules that the FAA could put in place. You tell me, you get to pick from any of these which ones you want. So if more than 50% of the people said, well, 2. Agreement to operational guidelines for self-regulation, a self-declared intent of the aircraft and general location and use. Anything after that is below 50%, and it's probably not a favorable rule. I asked the question in reverse. I said, what is an unfavorable rule? And you'll see that in a minute. Come on. There we go. Under unfavorable rules. Real simple. Tried to just graph it as simply as possible. I have lots of data to back this up. 61% of the people said, we'll shutter, or we'll kill our plans. That's it. Unfavorable rule. We go out of business. 39% would say it. We concluded basically that the overall market would just basically collapse and disintegrate. Unfavorable rule, what is it? Well, it's all those above the line. Commercial pilot's license, private pilot's license, certificate of authorization or waiver, Part 21, 25 restricted category certificate, Class 2 medical certificate. Okay, some people said, well, private pilot ground school, okay, maybe maintenance records of my aircraft, okay, aircraft-specific operational proficiency test, okay, serial number traceability. You know what's interesting? Is that only 12% said none. So most people want some kind of regulation. They think it's fair to have some kind of licensing, but not so that it's not egregious that it cuts my business. Okay, I'm going to let you read these. These are on the slide share. I made 5 recommendations to the FAA, and I made 5 recommendations to those of you who are in business and are SAS operators or aircraft sales. I'm going to point out 1. I think the one that matters is number 4. On February 6, 2007, there was a policy statement advisory pledge to create a different category of unmanned vehicles that defined the operator's visual line of sight and also slow enough and to adequately mitigate the hazards of other aircraft on the ground. And I also like this other one. Sorry, I want to say this one. I looked this up. There's a thing called the Regulatory Flexibility Act that requires federal agencies, when they put rules in place, to balance the safety goals of the regulation with the needs and capabilities of small businesses and other small entities. Okay. Recommendations to you, those of you who are operators, besides the buy insurance, find your public voice. Please find your public voice, voice your opinion. When the FAA notice of proposed rulemaking comes out and UAS is made public, don't assume that the AUVSA is looking out for your behalf. I've written about that. You can see it. I've blogged about it. I've talked about it. Should be pretty clear to you. Anyway, if you have any questions, you can talk to me afterwards. I'm happy to answer any questions. I've got these reports available. I put one out there for 95 bucks so that it's in reach of small businesses. If you want more data, it's in the complete report. Thank you.
So definitely some interesting information. And one other thing I wanted to talk about, we have another guy here who's going to be giving a short presentation, but one other thing with the NPRM, and this is why you need to be proactive about this, and I've talked about it for years, but in this context, when the FAA puts this out for comment in the NPRM, they are under, there's no law or anything that says they have to change one word of what they're proposing. And you could come up with the most educated, concise, pragmatic suggestion. They don't have to do anything. Thank you very much. Have a nice day. Here's what you're getting. So you got to get proactive and get in front of it beforehand. Interesting study, interesting information in there. Thank you, sir. Okay, our next speaker, because we're staying on track here, is it Gary Hethcoat? Hethcoat? Okay, and he's going to tell you about UAVs and additive manufacturing. Thank you, sir.
Thank you. How you doing? So I was down at Northrop Grumman about 2 years ago, and working on a documentary film there called The Hitler Stealth Fighter about the Horton 229. And I was talking to their guy, their additive manufacturing guy, and he very proudly took me over to his shop and showed me his equipment. And just told me straight out, he thinks that within his lifetime, and he wasn't a young guy, they would be growing aircraft and literally dusting them off, putting fuel in, and flying them away. And at the time, I kind of thought, okay, well, he's a visionary, and it sounds kind of like science fiction. But I'll tell you, in the 2 years since, I completely believe, now I don't know about his lifetime, that of course depends on how long he lives, but I think I'll see it. I really do. And so let me tell you a little bit about what I've done. So what I really wanted to do is I just set out to see what could be done with just low-end equipment. Okay, I'm a member of Tech Shop, and they have these low-end 3D printers. And I thought, okay, is it possible to make actually a complete airframe? So I did a design in SolidWorks, which you see in front of you there. And let me see if I can figure out the navigation. And here's the low-end printer. And this is a kit printer. This, I think, well, they got for free, but I think something like this at the time you could get for less than $1,000. And very simple. And I just designed with somewhat with the machine in mind, because part of the problem currently is the machines are kind of limited. But how this thing works is it's got an extruder that's on an XY, a couple of stepper motors that control it in XY, and then it's got a build plate underneath. Okay, so the extruder squirts out like a little 0.2 millimeter sort of extrusion of plastic, and then the build plate moves down. So you extrude one layer, and then the build plate pops down. You extrude the next layer, it pops down again. You extrude the next layer. So you build up this part out of extruded melted ABS plastic. Okay, so part of the problem is that whole process, it's error prone. So if you're interested afterward, I got a whole bunch of parts, including some that are like fresh off the printer, so you can see some of the limitations and what things it does. But little bit about design. Of course, one of the great things is your complete design freedom. You can build any shape that you can imagine. If you can build it in SolidWorks or some similar tool, you can print it. But it's not quite that simple. Great thing is, like everything you see here, all this structure here, servo bay, mounts, hinges, control horns, everything, it's all printed right in, and you pull it off the printer, and it's, in theory, done. And nearly zero labor. The downside of that is it's actually a lot of print time. Even for a small part, you're talking hours of print time. So, we're not at nirvana yet, but it's still very interesting, and that's why I did it, because I just wanted to kind of understand the state of the technology. So, 3 minutes. Okay, yeah, and the machines currently are not that reliable. A lot of times you'll get false starts. You'll throw away a lot of parts, start over again. All right, but when it works, it's great. So the way it works now is you have shells. So the outer part of the part has shells, like I say, 0.2 millimeters. Usually you put at least 2 shells around the outside, and then the inside is fill, which by default the software produces this kind of honeycomb-shaped fill. So I did not design that. The software puts that in for you, and then you end up with a solid part that's got this honeycomb fill. Okay, so I knew I didn't have much time, so I didn't have that many slides. So the promise is clear. I mean, you can see that this is going to be huge eventually. Right now, it's pretty limited. It's, the materials and the techniques and so on. Takes a lot of print time. The parts are kind of heavy. I mean, I built a lot of planes out of wood, and this is, it's really hard to get the weight down the same as wood with the same kind of strength and flexibility and all that stuff. And of course, we need bigger build volumes. I mean, you could, if you're going to go out and spend 6 figures, you can get bigger machines, and there are people doing that. But, at a reasonable cost, at a reasonable time, we need stronger materials for sure. ABS has got its limitations, and that's the best material you got right now for low-end printers. So, time for a question? Any questions? Yeah, I've got parts. If anybody wants to come by and see parts that are actually printed, I can show you samples. Okay? It has not flown yet. But check out the website. I'm going to keep posting stuff as I get closer to flying. Part of the problem is it takes a lot of print time to print these parts. I'm sharing the machine with 50 other people, and everybody's abusing it, so it's broken half the time.
You got one question?
Yeah.
Quick.
I guess how many
Okay. Yell it out.
All right, well, anyway, have you found you have significant variables from machine to machine? Sorry, I swallowed wrong here while tackling this thing. Do you have problems with run-to-run, either the same machine or machine-to-machine problems if you only use one machine in your prints? I've run into significant issues even on small, not terribly complex parts for UAV.
Yeah. Well, I've only been using the one machine because it's the only one capable of ABS. There's another really common material called I think it's PV something. Anyway, it's not heat tolerant. So, but the problems I run into is that the machine has to be adjusted just right in order for it to work. Everything has to be perfect. Build plate has to be perfectly level. The extruder has to be working just right. And if anything at all is wrong, you'll get the part will start and it'll fail, and then you just start over again. So, but yeah, it's the technology is amazing, but it still needs a lot of work.
Thank you, sir.
All right.
We're just buzzing right through here. Our next speaker is co-founder of the RCAPA. His name is Mr. Gene Robinson. He's going to tell you a little bit about it. Everybody, please welcome Mr. Gene Robinson.
Hey, folks. been instructed to keep it kind of short, and people who know me will attest to the fact that I always follow instructions. So the RCAPA, the Remote Control Aerial Photography Association, was formed in 2005. It was formed by two guys, myself and Rick Connolly, who couldn't be here today, and that's why I'm here. And both of us have aviation backgrounds. He is a certified pilot. I received my FAA certified pilot rating back in 1976. So we are not newcomers to the field. We were lionized early on because kind of felt like that we were poking the dragon with a stick, maybe trying to instigate the formation of rules. We met for the first time 2005 in Reno, Nevada. And if I can get this next slide up, you'll see this merry band of men here. We're the beginning. Rick Connolly is on the left, myself there, and you'll see Mr. Egan there in the back peeking in. And interestingly enough, we were there, we met with an agribusiness interest as well. It was Simplot. They control hundreds of thousands of acres, and they were interested in using UA back then to deal with their agribusiness. So, as pilots, we knew something was coming. We had peeked into the dragon's den and saw what the dragon could bring. So we tried to produce a community-based consensus of a standard for unmanned aircraft, for commercial unmanned aircraft, because we recognized that this was going to be a business. This was going to be a big business. We also knew that small business people were going to have standards to build to get by with the regulations, to appease any regulatory faction, such as the FAA, to get out into the world and use this. So in 2008, we came up with the proposed sUAS NAS integration guidelines, and it was presented to the FAA. We had hoped that they would take this document and use it to produce some sort of common sense regulation. Now, I would highly recommend that if you're new to the business and you're starting your documentation, this is a great place to start. This is your FSOP, your Field Safety Operating Procedures, already done for you. You can take that document, you can incorporate it into your field service manual, and a significant portion of that work is already done for you. So, with that said, we are resurrecting RCAPA again, the Remote Control Aerial Platform Association now, because we recognize that not only are there fixed wing, but they're multi-rotors, lighter than air, and everything else in between. So we are trying to build this advocacy again for common sense regulation and to provide a unified voice, which is something that we have in our charter since 2005. So we would like to encourage everyone to go visit our site at www.rcapa.net and see some of the things that we've done. Mr. Egan has been involved, your host has been involved since the very beginning in procuring liability insurance, producing procedures like these, producing training materials so that people who are newcomers can easily transition into it. And it's been a lot of work and a lot of effort, but it's there and it's free for the taking. That's the best part about it, is that it's free. So we would like to encourage everyone to throw your voice in with all the other voices so we can speak in a unified voice. Thanks.
Yes, it's a good starting place, and people can go there, like Gene said, and learn about some of the history that we've done. We've been giving them hell for many years now, and hopefully now that things are picking up a little bit, I'm going to be able to dedicate more time to ASTM, RTCA, and the FAA, and hopefully get us something where we can operate where they're not going to kill us with regulation. One thing for people that have been to the Paris Air Show and you've seen the chalets on the flight line, it would appear that the aviation companies, the ones that make planes, are making money. The people who are not making money are out there trying to run 135, say Part 135 businesses or other businesses are making $10 an hour, you know, or even the guy sitting in the right seat started off in a regional jet for $12.50 an hour. That's not where I want to be. I want to have a real professional wage and a business. So go to RCAPA, sign up, get involved, write your elected federal representation and tell them we don't want the DOD and the asymmetrical warfare overlay. We want to be able to do business. Our next guest, now this guy called me and he's a wild man. He's burning the candle on both sides, and he works for the California State Parks. And he didn't put his name up here because he's burning the candle, and I forget your last name, but your first name's Paul, correct? And he's going to come up here and tell us what he's been doing for California State Parks. This is right up our alley. Please welcome Mr. Paul Bays.
At what % saturation are we yet? It's my position, Patrick, thank you. Penultimate speaker, the most forgettable presentation of the afternoon. Okay. So I have an aviation background, a passion for photography, imaging, and I am a connector.
Can you hear in the back or no?
I am a connector. So I do not have a policy role in UAS at state parks. Patrick invited me to speak to give you a little glimpse as to what state administration is thinking about, what we've actually accomplished. We're a one-flight wonder so far. Are there any representatives of state government here today? One. What? Okay, I'm in good hands. So here you have it. I'm not going to read it again for you, but we are focused on only 3 things. This is my personal exhortation of everyone. Safety first, accuracy. This is a bid to the mapping professions. And then efficiency. After all, we need to do it in a cost-effective fashion, particularly in the beleaguered agencies such as mine. So I exhort you also. The only reason I'm here alive for you, because I have 2,000 hours of professional aerial camera work, is because of what I know and because of the pilots I flew with and what they know. So remember, you do have to know everything about your system and about your mission, and you need to communicate that effectively. And you need to be patient. Something about old pilots and bold pilots and who's here and who isn't. So we have been operating on a single site, and we have a single COA for the Trimble UX, and not the UX5 yet. Let me just, I'm going to rush, so I'm just going to jam through this. The process started with getting Major General Anthony L. Jackson, our new director of California State Parks, not so new now, about a year, coming to save us from our public relations issues. So he signs off and says, Paul, go do it. But before you do, you have to prove to the FAA that you are actually legitimate. So we needed 2 letters. That took almost a year to get out. But once we have those letters, then we're eligible to apply. It's kind of like a mother may I. We accomplished that. The next thing I had to do was to convince our survey section, because after all, if I can't get a credible user community, then there's no point in conducting the research, right? You have to end up with something practical. We are not a university, we are a service organization. So then we have to agree to get something for free. Trimble kindly agreed to do that. And then finally, arrange approval for the operation itself at Prairie City State Vehicular Recreation Area, our off-highway vehicle park, eastern Sacramento County. Then you need a mover and shaker, someone that is also a connector, able to bring the various factions together. And then the operative element is the second to the bottom line, textbook success. I have to tell you, if you're wondering, if you've arrived here to kind of watch and see, I can assure you, it works. The processes, the technologies, and the integration is happening. So we're hoping to continue with another scheduled flight in June. So this is a progression. You saw generally where we are in Northern California. Do choose an approvable site. You can see that there is a lot of remote land away from urban areas where we operated, and that's typical of also off-highway vehicles, so we're not really offending anyone. This is a perspective on the site itself. The particular location is a gravel pit under rehabilitation. So we had a little diversity of terrain, little cover type, and lots of clearance from conventional aviation. Do know your aviation parameters and situations. So that's where we are, well away from airports, well away from airports. So this is the proof of buy-in by the Chief of Surveys. You need to have ground control. Who was the gentleman? Rory? Still in here? Thank you for that remark on ground control. We need community for ground control. You have to involve a lot of people, collect the information, and share it. So there is the scale of the aircraft involved. This is the Trimble Gatewing X100. A little close-up, just pre-launch. And 15 minutes of flight produced 60 acres of coverage to about 1 foot accuracy. So this is over-controlled, you could say, because we wanted to have a fair and open process for evaluating the accuracy performance of the aircraft system's full threat. So in those 15 minutes, enough data were acquired such that 4 hours of processing produced a digital surface model. I would not have believed it had I not seen it. And then just to prove to ourselves that we were in range through the courtesy of Caltrans Photogrammetry and TOW Mapping Incorporated, helicopter LiDAR flight was flown over the same target field. So here is the money is the error in elevation. This is usually what surveyors are after. Horizontal, yeah, that's easy, we can do that. It's the vertical that's difficult. And so we had 5 knowns that we provided, and those are the ones in blue. And here is my, I'm not a surveyor, so this is my amateur attempt to measure the results from the flight. And look at that, inside 1 foot. And then I've hidden the hundredths of the foot data to keep my Chief of Survey happy that we are remaining objective about evaluation of systems. But look at those vertical results. 1 foot, I'm very safe. I've been authorized to say it's 1 foot. And then here's the LiDAR. 1 foot, not good enough. So there's the hundredth of a foot, or the 10th of a foot category of accuracy. So what will you take home? Safety, accuracy, efficiency. Drive your thinking and operations around those things, because ultimately you have to prove efficiency, but you will go nowhere if you have mishaps. Okay? Huge setback. Politically, operationally, personally, possibly. And we want to stay squarely in the land survey and facilities management for our research purposes. Lots of motivated individuals doing search and rescue and other things. And remember that patience. Thank you. Question? No question.
All right. Moving right along. We have a schedule to keep. It's like I'm a trained guy. Okay, we have our last speaker, and I don't want to massacre your name, so you can come up here and say it yourself. And after his presentation, his company has sponsored a reception, beer and wine, and cheese and meat platter. So please welcome Mr. Wolfgang. Thank you.
My background is in aerospace for over 30 years, and yeah. But how can? Which one? Oh, okay. For over 30 years, I was working in the aerospace industry, from engines to airplanes, helicopters, all kinds of aircrafts. Our goal of my company is to create a flying cargo drone, but because the way to get there is not so easy, we start developing a small-sized drone to be used for different special applications, mainly to develop for special services or to bring help to area where it's not available. Here today I was seeing about drones, only about the flying drones. Drones are even the cars. Using roadable features in order to go and get help or bring people back. I'm showing here all these applications that you are used for drones, for military, for border control, for highway patrol, delivering pizza, flowers, whatever needed. Checking the pipelines, power line, electrical lines, or wild animal search. Different areas are exploring different power plant damages or different mine searches. All these development which I'm showing here, this presentation was mainly, I was coming from Europe and the presentation was done for some European customers for flying car mainly, and in the States we develop these small-sized drones on the same principle and the same technique. We develop this type of vehicle, which is a foldable vehicle. The name was FIPSI because it's coming from Flying Innovative Personal Space Icon. FIPSI is including inside this body well-known technology. This is a patented technology. Both of the developments are patented. We use hinges, we use engines, we use flight controls, we use whatever technology exists on the market, and we try to package together to make a new vehicle which is very effective on the ground and on the air. The regular look of the vehicle is looking like a car, and it's like becoming a quadcopter in the moment when it's deploying the rotors and closing back the doors. This is the first drone we used and we sold, and now we are developing like a mass production, if you can call, for the same type of vehicle. The main customers are more special services like ambulances, police, fire departments, and different rescue forces. General development was not talking about the flying cars. Was the initial concept was to get to one point to another point using the flying option. But many times, going to one point to the other point, you have to use a runway. And you have to go to a small airport, go to the next airport, and go to the maybe opposite direction just to get there. Using this type of vehicle, you can stop in any side part of the road or parking lot, and you can deploy the rotors, and you can take off and land in the other place where you have the GPS coordinates, and you just put the GPS coordinate there, automatically can go there. It's a lot of flight control implication, a lot of satellite communication in order to get you to the right point in the right time. Like I said before, this is a deployable vehicle. Just open the rotors, close the doors, and ready to go. These are showing, here we can show some of the deployment feature of this car, of this drone that we did it, the initial one, only the rotors. The one with having the wings is the one which we are in the process of developing now. It's a long way to go because it's implying a lot of technology for flight controls. We work with local Collins companies and some other company developing different software for controlling this vehicle in the air. This is the other principle of the other type of application. Usually the existing one which I created is taking a lot of energy and consumption, electrical consumption, because having the type of helicopter flight, all the lift will be on the rotors. This new development will be able to just minimize the consumption, having the lift created by the wings, and only the takeoff and landing will be created by the rotors. In all this design, which we have in production, there are a lot of high-tech components, all kind of fancy materials. The small size drone is having like 30 inches length and 15 inches wide. It's a small size remote control quadcopter combined with a shaped cargo. Here's another type of presentation we developed. It's almost the same principle, but it was created to just have an idea for people which are not aware how this can be applicable on the real life. Mainly being a close body. A lot of times when we talk with different customers, they said that delivering different option of medicine or packages to the point where they want to deliver, they have to go only on the wet, on the dry environment, on a nice day. If it's raining or if it's bad weather, all the packages and all this medicine can get damaged. That's why we came up with this type of vehicle. It's close body, and everything will be delivered inside the body. This is the one that we created and we have in the production, the small size quadcopter size, and we look further for new markets in Europe and anywhere else we can find customers for this type of small size drone. Here is just the flying car application, but we had customers purchasing this for just like a small remote control option. The other new development which we have on the company is the other size, the other shape, containing wings, deploying the wings, creating more lift and longer range and high speed for the vehicle to be delivering these packages to the needed area. Our intended goal is to be able to deliver solution for emergency situation where we can ship the needed help, medicine, whatever you need it, faster, anytime and everywhere. are in discussion with some investors which try to found this full-size scale, which is not so cheap like any drone. Full-size scale model is costing a lot, and it's taking a lot of mathematics calculation and safety for the passengers. The advantage in the case this will be used like was supposed to be like a flying car. This can be parked anywhere, can be taken off the land any place. Not going to any airport or losing time going maybe in opposite direction to just pick up an airport. In the States, there are around 60,000, 60,000 small airports, which can be used by operators. The main one are only 25, 30 major airports. But even these 60,000 airports are not delivering the places where you really want to go. If you are even in San Francisco area, you have to go to an airport to just cross the bay on the other side. It's better to just take off from one place and go to the other side of the bay. Here is showing that this technology is patented. It's outstanding patent for both products. Like a small size unmanned vehicle, the one that we created can be used like each operator, the same like filming, toys, or for special services delivering different search and rescue missions where they need it. I will go for the big size you can use for ambulance services, fire department, flooding area, earthquake search. I'll put the last video for these things. We're showing the application, which can be if this would be like a big scale model. If you are in the congested traffic, I don't know where it's not going. Deploying the wings, you can take off from any place. This type of small drones was developed and was advertised in Europe, like Lamborghini was presenting something, Renault presents some other type of drones which they claim that they can go avoiding the traffic, but if you get stuck in the traffic, you cannot move, so you just have a drone which will see the traffic around you, but will not be able to just move your car away from the congested area. It's showing here like a high-rise building in fire. You can take up any person from there. This is intended to be an unmanned vehicle, just to be able to just go and open the hatch, the lift gate, front lift gate, and bring the needed help back to the safe environment. Like in flooding area, next side would be, it will be an earthquake or a world area where you can go in any area searching for people or searching for remaining in the buildings. For military application, we discussed providing this type of vehicle for different deploying men in different areas for mine searching or war zone, will not be needed to risk people's life and just send this vehicle, take some data from the area and come back and rescue. It's not an electrical, it's driven by electrical motors and electrical power drive, but it's a gas powered engine which is providing electricity for the motor. It's a battery backup, but mainly it's a gas engine and it provides electricity because it would be easy to just do fly-by-wire control and electrical maneuver for the vehicle. That's all. We are located on the East Coast, and I heard about this show. I was knowing Patrick for some time, and I've been in Europe. When I heard, I just sent him the presentation and just came back here and tried to, let's say, show you like some future development. It's not something which can be applicable today, but it's like a more technology, tomorrow what. That's all. I think that no need for question. Everybody can dream to any potential application. If somebody wants more information, they just see the information on the site and can call us and get more information. Thanks.
Okay, now, I just wanted to say thanks to Craig. Craig did the posters. He's the guy that did the artwork on that. And we actually have little ones for sale up front. If you want to take one home as a souvenir, you can talk to Veronica. I want to thank Gus for helping us out. He's the videographer. We will have all of these presentations will be on the sUAS News YouTube channel. You can also watch the stream today. 10,000 people were invited to watch today's program all around the world. So, with that said, Advanced Systems Engineering has sponsored or is hosting our reception, and you can go outside and there's some nice California wine, and there's plenty of beers, and there's some soft drinks or water, and there's also meat and cheese and whatever else. Go out there, have a drink on Advanced Systems Engineering and network with your friends, and then be back here tomorrow at 8:30 to register. We're going to get the program rolling. We got another full day, and it's going to be great. So thanks again, and I hope you enjoyed yourselves.
Okay. Philip?
Hi, Gary.